C#, aesthetically strongly typed, cross-platform and general-purpose programming language. But what does that actually mean? C# is a programming language designed at Microsoft and open-sourced in 2014. I would describe C# as a Swiss Army knife of programming languages. So it's not the best at anything, but it's pretty good at anything. I could name 100 features that I like about C#, but what's really notable is that it's especially good for building larger applications, including enterprise apps. It's very well documented, and it's general purpose, so you can easily build programs such as desktop applications, web applications, mobile apps, and games. This is a fundamentals course, so you'll learn everything you need to know in order to get started with C#. The learning structure is as follows. We start with a lection that contains usually some theory. Next, you'll do an exercise on your own, so it's important to pause the video, do the exercise, and then look back into the lection what you haven't understood correctly. With this feedback loop, you'll really understand the concepts and learn how to program. After that, you can move on to the next lection. Before we start, we need to install .NET and Visual Studio Code. While you could use another IDE like Visual Studio or, for example, JetBrains Rider, this course is gonna use Visual Studio Code, specifically because C# is cross-platform and you can follow this tutorial either on Windows, Linux, or Mac. From my point of view, this is an important choice. Because you're learning a new programming language, that means you should learn how it works under the hood and not what an IDE does there for you. On Windows or macOS, the setup is pretty simple. Go to the site .NET.microsoft.com and download the .NET framework there. We're gonna go for the .NET 8 version. When the download has finished, simply click it and follow the installation instructions. After finishing the installation, open a command prompt or terminal on macOS and type .NET-version to verify that you've installed .NET successfully. Now it's time to download Visual Studio Code. Go to code.visualstudio.com and download Visual Studio Code for macOS or Windows respectively. After the download, simply click on the installer again and follow the installation instructions. On Linux, you can simply use your package manager to install .NET. You can, for example, use apt, search for the current .NET SDK version, and then install it with an install command. That's it. At the end, we also want to make sure that we have the correct version installed by typing .NET-version. For the sake of completeness, there is a possibility that your distribution does not support .NET officially, and you have to add the Microsoft repository for installation, but I'm sure if you're using that kind of distribution that you are ready to set this up manually yourself. For Visual Studio Code, we have to go to code.visualstudio.com, download the Debian package, and after it's downloaded, we simply install it by using apt or your other package manager. This, of course, depends on the distribution you're using. In this case, I'm using Ubuntu. Okay, so that's all what we need to do in order to run C# programs on Linux. So it's finally time to run our first C# program. In this tutorial, we're gonna use the command line to set up everything we need for our project. While in the future you will probably switch to an IDE, an integrated development environment, at some point, this will do a lot of this setup for you. However, you don't have the exact control over what you're gonna do there. First, what we're going to do is create a small project structure. For that, open up a command prompt and type in the command mkdir for make directory. I'm gonna call it C# fundamentals. To enter the directory, we're gonna type cd for change directory and C# fundamentals in order to enter that directory. Now I'm gonna create another directory called hello world and enter that directory. What we're gonna do now is create a console project in this directory here. And we do that by typing the command .NET new console, which means we're going to create a new console app here. So the restore succeeded. Now we can type in code with a period, which means open Visual Studio Code exactly here. The first time we open up Visual Studio Code, we have to install C# language support. So we go to this extensions tab here, search for C# and install the C# base language support. So now we can go back to the files, which is done by clicking on the Explorer tab here. Here we can see that we have two files in the Hello World folder. The first one is called Hello World CS project, which stands for C# project. And here we can see it's a Microsoft.NET SDK type project. And the output is an executable file. We are doing this for .NET 8. So the framework version of .NET is .NET 8. Now we're going to open the program file and we're going to press F5, which means we want to run this program. So first we have to select the debugger. In this case, it's always the .NET 5 Plus debugger. Now we can see that VS Code has created a .VS Code directory, which contains two files necessary for running and debugging C# programs. Go back to the program.cs file and press F5. Now we can see that VS Code has run our program, which outputs hello world. The orange output that you can see down there in the debug console is simply debugging information that you can ignore for now. So let's have a look at the code itself. We only have two lines. The first line is a comment, which you can see in green, and it always begins with a double slash in C#. So this is useful, for example, if you want to document something. The second line is the actual code, which is a console.write line, hello world. So in this case, we tell C#, please output hello world in a new line. When we want to program something, there must be a way to store information or data. For example, we might want to store the username, or we might want to store a whole number, we want to count something, etc. So there must be a way to store this information. And this is done by variables. So what's a variable? Well, a variable is C#'s way to use the computer's memory. And whenever I say computer memory, I want you to visualize this as a flat array of cells. So you can write data to these cells and you can read data from these cells. And I could, for example, store a number like 42 in this cell. The precise mechanisms of how these different types of data are stored in a cell are not very interesting for us now, but I will offer a few deep dives to this topic in the future because it's important in a few cases. But how would you write this in C# now? Well, in C# you would write integer int x equals 42. So this tells C#, please store the right-hand side, 42, in a cell, and it's a whole number, an integer. And whenever I type x in the future, C# knows, please look up the memory cell here and return this value for us, and search what's in this cell. So you could also imagine the term on the left here, what you write in C#, as an assignment. So the equal sign has no mathematical equality. It's not a condition, for example. It simply means takes a term on the right and assign it to an identifier on the left. So you can imagine it like this. And the good thing in C# is you don't have to care about the memory management here. So we can get rid of the memory on the right here. So I'm back at our program and I made some adjustments here because I want you to see an example of when you would want to use a variable in practice. So instead of writing only one line to the console, that is the output of the program, this is going to write 4 lines of text to the output. So when I press F5, you can see that C# has printed out all of the text that I've written down in the quotes here. And the text says, hello to wine tasting. There are 4 wines in a basket. Each of these 4 has a different flavor. While there are more wines, 5 bottles are enough for a tasting. And in the last line, you might have spotted this, the 5 is a mistake. So we only have 4 bottles of wine in this tasting, and this should be the number that's written down here. And now I could go in here in the last line and change this from 5 to 4. But, well, imagine this is a real program. Then you would not have 4 lines of text here. You probably would have an output of, let's say, 400 lines. And then it will be very hard for you to keep track of the correct number of wines. And this is something where C# and variables come into play, because this will make it much easier to keep track of the number of bottles. We simply store it in a memory location and use the memory location to remember the correct number of wine bottles. So let's start by typing int for integer, x for the number of wine bottles, that will be the identifier, equal to 4, semicolon. So I haven't talked about the semicolon part before, but simply imagine the semicolon to be a statement delimiter. So similar to what you write in a text, where you end each line with an exclamation mark, a period, or a question mark, in C# you have to end each of your statements with a semicolon. Okay, now let's execute the program again. And we can see that nothing has changed. So we still have the mistake here. This is because when we executed the program, C# starts with this line, prints out this text, and then prints out the other ones again. And in this line, C# has assigned the identifier x, to a memory location that stores the value 4. But this is never used. So when I hover over this variable, the editor, so VS Code, says this is not used anywhere in our program. So yeah, please do something with it. So let's move this up here. And what we're going to do now is we're going to adjust this and concatenate text. So we first have to end the there are part. Then we have to write a plus. That means concatenate this with a variable x that stores our number of wine bottles, plus and quotes again. So we do this in every location here. And also in the last line where we did the mistake. So let's save that again and execute it. And now you can see that the number of wine bottles is correct. And when I change it now, so when I have, for example, instead of only having 4 bottles of wine, I have 5 wine bottles in this tasting. Sorry. Let's say I have 5 bottles of wine, and I press F5 again. The text is adjusted accordingly. So variables give you a lot of flexibility instead of changing the number of bottles everywhere in your text, we simply go into one place and change it there. And then the text output of our program is adjusted accordingly. So let's zoom in a little here. I want to repeat again what this stands for. So plus in this case means when we work with text, it means text concatenation. So this means concatenate the text there with the value of the memory location, x, so this will be 5 in this case, and then concatenate this with wines in a basket. So this is why we're gonna have the text line here, there are 5 wines in a basket. So plus simply means text concatenation. And as a last note here, it's not a good idea to name your variables x because, well, the next programmer that will have a look at your program, he won't know what x stands for when he reads this line. So yeah, go over or hover over the variable, press F2. This means we want to rename this variable and let's call it number of bottles. Press enter and now we have adjusted the name everywhere in our program. And now we can simply, have a better idea of what's going on overall here. As a first exercise, write a program that outputs a text about a person, and you should mention the age of the person several times. And then do as we did and refactor the text such that you're using a variable. And then imagine what would happen to the variable in your program when the character or the person celebrates a birthday. Let me show you my solution. So the first thing I've done is I've written down int age. And in this case, I haven't written down int age equals 17, for example, or I've only written down int age. And I just want to show you here that instead of writing and initializing a variable directly, like this, and saying store 11 in this memory location, I can simply type int age. And this means we need an identifier age, but we don't declare what the initial value will be. So I can do that later in the program. Then I write a console write line, I write down a statement about a person named Jim, and then I initialize this. So in this case, I say assign the value of 17 to this identifier to the memory location here. Then I use this in my program. And then I write something about his birthday tomorrow. And he's very happy because he can obtain a driver's license. And now he has his birthday. So what I do is I say use this memory location and assign a value to this memory location, take the current value and add 1 because, well, if you have birthday, your age is increased by 1 year. And this means when I'm down here, the C# will say this is 17, add 1. So we have 18 in total and stores this in the identifier age, in the variable age. So in the next line, this is going to be 18. So in this line, we're going to have the result 18. Now, when I press F5, we can see that, well, it's 17 here, but after he has birthday, after Jim has had his birthday, he has now obtained his driver's license at the age of 18. So you can see that in this case, we have increased the value by 1. And yeah, I need 1 space here. Execute it again by pressing F5. So now it looks better. So now we can see that Jim is now 18 years old. Okay, now it's time to learn one of the most fundamental skill sets in programming, and that is debugging programs. So whenever you have to do with a program that you don't understand and you have the ability to debug it, you can basically go into the program step by step, and that will help you a lot when you basically don't understand what's going on. So in my opinion, this is one of the most important, if not the most important skill set in programming. Okay, so let's debug our program now. What do we have to do? Well, on this left-hand side of the editor, I can add a red dot. And VS Code tells me that I can add a breakpoint by doing this. So let's click on this fourth line here. And let's press F5. And whenever I told you that F5 runs the program, more precisely what VS Code is doing, it's starting a debugging session. So you can also run this without debugging, but I want to press F5, which means I can debug the program as well. So when I do this, I can now see that I'm in a debugging window here. So this is another tab. And this line is yellow, the fourth line, because what happened is that C# has executed this line, it has executed this line, and now it's about to execute this line, the fourth one. So when I hover over this variable here, I can see that this is actually 0, which means it hasn't been assigned a value yet. And by default, it's 0. I also have this new window here, and there I can decide what to do in the debugging. So I can only make one step. We don't have to care about teeth here. And I can jump to the next breakpoint, basically, which is F5. So what happened is C# has executed this line. We have printed out this line. So we can see this down here. This has been printed out. And we're about to execute this line. So when I press F10 or click here, this variable age has now a value of 17. When I hover over it, I can see that C# has stored 17 in this variable. And let's step over the next one. Now I can see that this has been printed out. So this text has been concatenated with the value of this variable. And we have added the text on the right, and this has been printed out. And when I would add a new breakpoint down here, for example, I can press F5. And now I've jumped to this line here. So it has executed these two lines together. And now I'm at this line. The value of age is still 17. But when I execute this line, age plus 1 will be 18. And this will be assigned to the left-hand side. So let's execute this. And now when I hover over it, I can see that age is 18. You can also see this down here on the left-hand pane in the debugging view. And now when I press F5 again, I don't have any more breakpoints left. The program will be run until it's complete. So now I can see the same output as before, but I could see how C# executed my code. So let's repeat this because it's so important. When you execute C# code, the code is executed line by line. So that means first we start with this line, then we go to the next line, then we go to the next line, and so on until we hit the bottom. And what you're doing in each line is obviously dependent on the code that is used here, but it's executed stupidly. So this means, stupidly, I mean, it does exactly and precisely what you write down here. It doesn't interpret anything else. So when I say age is age plus 1, C# will use this memory value, add 1, and assign it to this memory location. It doesn't understand if this makes sense or not. This is where you come into play and where you have to tell, by writing good C# code, what's supposed to happen such that your program makes sense. So let's do this again, just for illustration purposes. Press F5. We start with this line. So this has been initialized. Press F10. And it writes out each line, line by line. And this is how every C# program is executed. So far, we've only used an integer variable and text. And that's obviously not a whole lot. So we might want to use a sensor value in a real-world application. And that would usually be some real number and not an integer. Luckily, C# offers a lot of built-in data types that we can simply use. So let's have a look at those. Okay, so the first built-in data type that you should be aware of is a Boolean. A Boolean is denoted bool in C#, and it's either true or false. So it's only two possible values. We deal with Booleans a lot when we do control flow statements. So that means you might want to do some action A when a condition or a value is true, and when it's false, you might want to do some other action. And then Booleans come in very handy. When you think of the size of a Boolean, think of this as being 1 bit. So a bit is the smallest unit in computer memory. It's either 0 or 1, high voltage or low voltage. And that is sufficient to store the value of a Boolean. For integer types, C# has a whole range of built-in integer types. So you can see 4 here. There are many more types. But the important thing about integer types is that they have a limited range. That is what you have to understand when you see this slide. So a byte, the first row here, is 8-bit in size. That means we have 8 zeros or ones, and it can store a number from 0 up to 255. So no negative numbers, it's unsigned. And because of this limit, 8-bit in size, we can only store this range. When we see the next row is short, this is double the size, so it's basically 2 byte, 16-bit. It's signed, so we can store negative and positive values. And this means you can store a much bigger range in a short. So one thing you have to note in this line with a short is when you see the example value of 20,000, you see that an underscore is used. So you can write this number without an underscore, but C# has these underscores when you write numbers because they make the number much more readable. So you can use those. Next is an integer or int, and int is double the size of a short, which means we can store even bigger numbers in there. And finally we have long. Long is even longer, and that means, yeah, we can store even bigger numbers in the long. One last thing to note when we see this row of a long is that I've written L as a suffix here. So let me mark this. So this L, you don't have to write it down, but when you see it, this means this number is a long. When you ever encounter this, remember it's a long. C# offers 3 real number types, so 3 floating point numbers. The first one is a float. A float is 4 bytes in size. Double is basically double a float, 8 bytes in size. Finally, we also have a decimal type, which is 16 bytes in size, so it's very big. Floats are stored in scientific notation, so that means we don't store all digits precisely, but we can only store certain digits. So we have a big range here, but you have to understand that when you use a float, for example, that we only have 6 to 9 digits of precision. The other ones won't be represented precisely. And when you see the example row in the first one, a float, you can have the suffix f when you use real number types. That means this number is a float. For a double, you can use d, and for decimal, you can use m as a suffix. So when you see the second row, we have a much higher precision. And when you see the last row, compare double to decimal, you can see that double has a much bigger range of numbers that it can store than decimal, but decimal has a much higher size. So it's double the size of a double. This is caused by the fact that decimal is there for storing high precision values. So as a rule of thumb, when should you use what? Use float and double for natural real numbers, so to speak. That means for example, for sensor values. But use decimal whenever you use human invented numbers, like money, for example. Then you should use decimal. And the last one is text types. So for text, we have a char, a character, and that is, for example, just an A in single quotes. And the range is basically a Unicode number or character. So this can be all of the Unicode characters. Its size is 16-bit, so it's UTF-16 encoded. And then we have string, which is basically an array of characters. So it can be all different types of text. And it's basically 0 up to n Unicode characters. Okay, so it's time to use the new data types that you've learned about. For that, I'm going to create a new project because I want to keep things separate. That means you can always come back to the code we've written and see what we've done there in case you have any questions. I'm at a command prompt in the C# fundamentals directory. Simply use a terminal in case you're on macOS or Linux. So let's start by creating a directory called datatypes, then cd, change into that directory, and type .NET in this directory, .NET new console. So we've created a new console project here, type code with a period, and now we're in our new program. We can press F5 again to start it. So the first time we create these build assets, you can add them as well. You say yes down here. Press F5 again. And we're good to go. Okay. So let's close the launch.json file. Go back in here. And let's declare a variable int x and output its value. So what's happening here? Well, we can see some red squiggling line here, and VS Code tells us use of unassigned local variable x. So this is one thing to note when you use this built-in data types. You always have to initialize them before you use them. So we can either do it by typing a value here and initializing them here, or we can declare them in this line and assign them a value down here. Just to be clear here, when you have this combined statement, we take the value of 42, we assign it to a memory location that holds an integer, and we want to identify this memory location by the term x. What we can do instead, we can only use the left part. This is a declaration. That means give me a memory location that holds an integer, but I don't want to assign a value yet. And later we can assign that value. So this is what we've done here. If we assign a value now, everything is fine. It's the same as before. If you delete this line, we have the memory location, but we never assign it a value, which is of course an error. So if you press F5 now, we receive an error, but when we assign it a value, everything is fine. So when we press F5 again, this is the same statement. Okay, let's use some other data types. So we will start by using a long. A long is bigger than an integer. So a long is 64-bit, an integer is 32-bit. This means we can store bigger numbers in a long. So let's do long L equals 42 and then add a console.writeLine, and type L in the brackets, semicolon. So this means output the variable L, which we stored here and which we said this should be 42. So we would expect to see 42 output 2 times when we press F5, and we can see 42, and this 2 here means it's been output 2 times. Perfect. Another thing that I want to show you is when we say we have a variable type L2, and just for the sake of completeness, when we type uppercase L, this is another variable. So lowercase and uppercase are different variables. Case matters when typing out variable names. Okay, so let's say we have another variable called L2, and we assign it a value of 42, but we add the suffix L. This means this number here is a long. And we can output that as well. And we have 42 output 3 times. So just to repeat this, this means the L suffix, this number before the L, this is a long. This is a long data type, or a number that is a long. So in my opinion, you don't have to write it, but if you ever encounter it, you understand that this means it's a long. Good. What we can do as well is we can say we have another variable called L3, and we want to assign it an existing value. So we can, for example, assign it a value of X. So that means look up what the value of X is, then assign it a value, and this should be identified by L3, and it should be long. So it's a new variable, but at that point in time, we capture the value of X. So in this case, we have 42 output 4 times, because we've outputted in this line, in this line, in this line, and in this line. Okay. What we can't do is do this the other way around. So when we say we have a variable called int y, and we want to assign it a value of a long, this is an error. So when I press F5 now, I can see it by the red squiggly line here, but when I run it, I get an error, and C# tells me, or Visual Studio Code tells me, I cannot implicitly convert type long to int. So why can't we do that? Well, it's simply because an integer only has 32-bit, but a long has 64-bit, and you cannot store 64-bit in 32-bit. It's just not enough space here. And don't wonder if you don't understand this precisely. I will offer another video about how the integer types work in computer memory precisely. But just for now, such that you know, you cannot do this. You can always implicitly convert. You can assign a value like X, a smaller data type, to a bigger one, smaller integer to a bigger integer, but not the other way around. Okay, so let's get dirty with some real numbers. So when I type float f, and I want to type, let's say 1.11, I can see an error. And what is this again here? Well, when I type a real number in C#, this means this is a double. So when we don't specify what this is in C#, this is a double. And float is smaller than a double. It's the same error basically as last time. Float is too small to store the double value. So we have to tell C# in this case, this is a float. So we have to add the f suffix. If you don't do this, C# doesn't know that this should be stored as a float. Okay. So when we do this, and add another console.writeLine, output this variable with a semicolon, we see that we can output this value. And we can do the same with the double value. So let's say we have double D, and we want to output 42.42. Now I don't have to add the suffix here, but I could add a D for double. That would work as well. Okay. And finally, let's do some text manipulation. So in this case, we can have a char. Let's call it C. So that's a single character. And we use single quotes. And that means only one character in here. So this, in this case, this is a A. And we can output this as well with a console.writeLine. Or we can have values like string. So in this case, this could be a string that can be any number of characters or an array of characters. And let's say this will be a text like there once was a man. And then I have a semicolon here. So we have this double quotes, and this means this is a string. And this is assigned to a variable called s. So when we write writeLine s, this will be output, the string value. So we've talked about different data types in practice now, but we haven't talked about bool. So your first task is to understand the different values of bool, how those are output to the console. And before you do that, imagine what they could be. Next, we've also talked about floating point numbers, so real numbers. And there I've mentioned that different data types have a different number of digit precision. So a float is, for example, 6 to 9 digits of precision. But what does that mean? What happens when we put a bigger number in a float with more digits than, for example, 9? That's your task to figure out now. Okay, let's have a look at my solution. First, I declare and initialize a variable b. So this is a bool b declared here, and I initialize it to true. Next, I output this to the console. Then I assign it a value of false and output it again. So you could imagine this as being true or false output to the console, or 0 or 1. We will see that later. Next, I declare a float f and assign it a big number. So this is big in terms of the number of digits that we want to store in this float. And then I do the exact same for a double and a decimal variable here. So remember, we have to use the f suffix when we want to say this number is a float. And we have to use the m suffix in case we want to say this is a decimal type here. And then I output out of those variables here. Okay, let's press F5. So what we can see is that true and false is output as true and false, which is good because this is human readable, but it's output in uppercase. Next, we have the float that is output. And here we can see that we can only store these 9 digits in this float in this case. So we cannot store the full number. This means only the first 9 digits are stored. Next, we have the double. We can store many more digits in a double, but it's still not sufficient to store all of those digits here. And the last one, the decimal, we can see that we can store the full number in here. So again, if you want to decide for a real number type, what you would do is, in case it's a human invented number, like money, you should use decimal because you don't want to encounter these type of errors in your program. But when it's, for example, a center value, a natural number, or a natural real number, so to speak, then you should use a double or a float. So far, we've only output variables and data types, strings, etc. to the console. But it's much more interesting to actually get user input and do something with it. So for that, we have to understand how to get user input and also how to convert different types of data between each other. Okay, so I'm back here at the command prompt, and let's create a new project in order to keep things separate. I'm going to type make dir, and I'm going to call this conversions. I'm going to type cd. We can begin with the and then press tab. This makes line completion, so we can now enter the directory. And I'm going to write .NET new console here. Oh, sorry. Perfect. And now I can open Visual Studio by typing code with a period at the end here. Okay, it's going to ask for the build assets. So this will, when we type yes, or we click yes here, this will create the .vs Code directory in order to start our C# program. Let's enter this program.cs file. And let's start by declaring a variable of byte. We call it b and assign it a value of 0. So what we can do is we can add a comment here by typing a /, and I'm going to type 2 to 255. So this means this comment will be ignored. This is just for us, the programmers, that read this code. And this basically means we have a byte variable b, and we assign it a value of 0. Okay, so we know this is 0, but imagine that b is mutated in a program. So this means we change it in some way. And let's imagine we have a long program here, and we might reinitialize b. So these are all comments, but we might reinitialize them, assign b another value, or we might do some operations with b. We might get some user input. And so we don't know the exact value of b here. But what we do know down here is, even if we don't read all of the lines of code here, we know that this is 0 up to 255. So this will not change, because b can only contain, b is a byte, and a byte can only contain values from 0 up to 255. And when I assign b to another variable, so let's say I have a short s, we have already talked about this, but I want to make this very explicit and repeated, because it's important to know that. And we assign the value of b to a new variable short. We can do it like this. So this assigns the value of b to short, and this is, I call this s. And if you think about this and remember the different ranges, integer ranges, you know that any b value will fit into this short. So C# says this is okay. You can do this assignment. And the same is true for int. So let's say I have an int I and assign it a value of s. This is also true, because, or no problem, because a short will always fit into this int. And we can do it with a long as well. So we can assign any integer to this long value, because this is 64-bit and this is a very, very big range, the long variable. And we could assign anything to L here, anything we've created up here. So we could assign b to this L variable or I, because they are much smaller. And the same is true for float. So if you have a float f and we say this is some value, remember to type the f suffix here, we can assign this value to a double. So this means take the value of float, assign it to the double d variable, and any real number, any floating point number that is in this float or might be in this float can be converted to this double variable. So this will never be a problem, because double is more precise than float. So we will not lose any information if we do this. And that is why this is allowed in C#. So if you really want to know this in depth, there is a page called the C# specification where you can read this up. So let me show you this. So here we have the implicit numeric conversions, and there you can read up any different types that you convert implicitly. But this is called an implicit numeric conversion, because we don't have to say explicitly in some way that we want to convert it. It is done automatically by C#, because we won't lose any information. Okay, so this is implicit conversion. let's go further. Let's say you have a variable j, and this is 10. And let's imagine this variable j comes from another program. So this is not from your program, it's from another program. Might be library, might be something else. But you know that this is 10. So it's maybe 0, 1, but it will not be bigger than 10. And you have no control over what this variable is. The code is already existing. You can change it. But what you want to do is you want to assign this to a byte. So you want to say, well, I'm memory efficient. I want to use a simple byte. This will be much more efficient. So what you will do is, let's say, call it bj, and we assign this to j. But there's a problem. So Visual Studio Code will tell us that it can't or cannot implicitly convert into byte. So this does not work in C# automatically. So this is not implicitly done. We must do this explicitly, because if you think about this, int will have can contain a lot of values. So this can be -2 billion, it can be +2 billion. So it's a very big range. And we only have values from 0 up to 255 that fit into this byte here. So this means C# does not allow this, because it doesn't know that this fits into the byte, this variable j. But we know, so we are sure that this is no problem. So we can tell C#, please just convert this, trust us. And we do it by typing brackets around this and the type we want to cast it into. So this is called a cast, because we say, hey, this is an int, but trust us, C#, we say this is a byte. So this will fit into a byte. And this is how you can make it work in C#. So this is how you cast one type into another type explicitly. So yes, in this case, I say, yes, it's an int here, j, but trust me, this fits into a byte. This is a byte. And put this into a variable. But I haven't talked about the fact that it could also not be a byte. So when I have an integer j that has a value of 1000, we can't fit this into a byte. So byte is 0 up to 255. We can store a bigger number in there. What happens now? Well, let's output this variable, bj, which is a byte, j casted to a byte, and it's actually an int value of 1000. So what happens now? So the output is 232. And this may seem weird, because why 232? And the answer is byte is 8-bit, int is 32-bit. So what C# is doing, it's saying, well, I, the programmer, say, this is a byte. So it's actually taking the first 8-bit and simply assigning this to this variable. So if this is confusing, don't. This is not bad in any case. I'm going to offer you a new video that will explain this in detail. But for now, please make sure that you never cast one value into another explicitly when you are not sure that you can do it. And finally, you can also do this the other way around with real numbers. For example, you can say I have a double. And so we already have this variable d. I can actually delete this line. Let's say I have a float variable, and this should be assigned the value of d. So this is not possible because double can have many more numbers, has a much bigger range than float. So I cannot assign the value of d to f2. But I can say, hey, C# trust me. I know that this was originally a float, for example. So you can simply convert it back into a float here. And let's output this. Don't forget the semicolon. Yes, so that works perfectly fine. So far, we have only output the text and variables to the console. So we've done this by writing console.writeLine and then put the variable or text in the brackets here. And we've also concatenated text with the plus sign. But the one question is, of course, how to get user input, because that will make our programs much more interesting, because we can do actions based on what we enter or what another user might enter. So we do this by writing console.readLine and then a semicolon. So this will give us back a string variable. So string is an array of chars. So basically it's just text. So I'm going to call this user input. And I say, assign this variable user input, what's been written or what's been entered in the console. Assign this to the user input variable. So what I might do after this is output the value. So I could type console.writeLine user input. So this would output back what I've written into the console. But let's add something here. So let's say you entered and concatenate this with the user input. So when we press F5 now, we are now asked to enter something. So I'm going to enter test, and this is going to get written back to the console with you entered concatenated with user input with the test value that we've entered here. So let's debug our program one more time in order to know what happens precisely during those calls. So let's go in here, set a breakpoint here, and let's set a breakpoint here to see what console read line will do. Press F5 again. So this will start a debugging session. So our program has executed all of this code. We can now see that J is in fact 1000 if we hover over the variable. We can also see all of the variables down here. And we can see what happens when we assign this to bj, which is currently initialized to 0. So when we step over this, we see that bj is now 232. And let's press F10 again and again. So we can also do this up here. And what happens if we press F10 now? Well, what happens is that the program stops. So in this case, when we execute this command here, console read line, C# stops the program, so to speak, and waits for the input from the console. So when I type in my input, we are back at the next statement. So with debugging sessions, you can see what happens precisely in your program. And now you can see that my input has been entered into the user input variable. And when we press F5 again or F10, we see that this is output back again. So just as a reminder, you can always use debugging sessions in order to better understand what's happening inside your program. Okay, so let's remove those breakpoints by going up here to run, say disable all breakpoints. And let's say the user has to input an age. So let's say we write here console.writeLine, please enter your age with a semicolon. Well, how can we convert this into an integer? Because, well, when we want to do some calculations, we need this to be an int variable and not a string. Well, from what we know, we could say int age equals user input. This would be an error, of course, because string is an array of characters. It's text, so we cannot, could be any text, so we cannot, or C# cannot convert it to an integer directly, but we could try to cast this. But as you can see here, this is an error. So C# says cannot convert type string to int. So this is not something you can cast, because string can be any number of characters. Int can have different formats. For example, you have a 1000 separator character that could be used in the string, and this is something that you cannot cast directly, because cast says, or the meaning of a cast in C# is C#, trust me, this is an integer, just convert this. No, there won't be any harm. But when we have text, it can be any number of formats, even if it is an integer. So what we have to do is we have to convert this to a real integer. So what we have to do is we have to use the convert class, let's say to int32. So we have to type convert dot to int32 to an integer and enter this user input. So what this is doing is it's saying, hey, this is a user input, it's a string, but do a conversion to an integer, and the result will be an integer. So this will be stored in this int age variable. So let's output this again. Let's say UR plus H here is out. So this is a very boring program, but it shows us how to convert this into an integer. So the program is waiting for us to enter our age. Let's say we are 25, and then it writes back this, you are 25 years old. So this has been converted to an integer and written back to the console. So now is, of course, the question, which data types can you convert into one another? And there, C# has this convert class with a lot of methods, like in this case, convert the input, that is a string in this case, to an int. And when you want to see what you can convert into one another, which data types you can convert into another data type, you can simply type convert with a period here. And you can see that there are a lot of methods, so you can use a lot of those built-in methods that convert one data type into another. So you can convert to int, you can convert to double, decimal, etc. So there are many more methods here that you can use in case you want to convert one into another. And I highly recommend you to try it out. So maybe you want to get some user input and convert this to a double variable, for example, and see how this works for yourself. So there are basically no limitations. It's a lot of the things that you could imagine that are already built into the language. Okay, so as a final note, I want to emphasize again, what is the difference between a cast and the conversion? So a cast is a type change, like here. So you say, it could be implicit. So in this case, we cannot lose information. You simply need a bigger range, for example, to store data into. So in this case, double can store much bigger numbers, and we might convert this implicitly from a float to a double because we need a bigger range. But it could also be explicit, like in this case or in this case, where we say, well, this is a double value, but we want to convert this to a float. And in this case, we use a cast and an explicit conversion. So this is called a cast. And this means that we are sure that this variable is actually a float, so that this can be represented as a float or as another data type. And we simply say C# trust us here. So this means this is actually another data type, and it's okay to use it as this data type here. And this is what is finally expressed as a cast operation here. Okay, and conversion, on the other hand, means we have something that we want to be transformed into another data type. So it might be without information loss, but let's say in this case, for example, we have a lot of possibilities how this whole number, how this integer could be formatted as a string. So let's say you have 1000 that could be typed as 1000 here, but it could also be typed like 1 with a 1000 separator character with a comma here. And it could have many different formats. And this means in this case, when we really want to convert this from data type A to data type B, and this might include information loss. So for example, when we have, let's say we have 1.5 and we want to convert it to an integer, this could be either 1 or 2, but it couldn't be both. So this would result in an information loss, but we want to do this, we really need this as an integer, then this would be a conversion. So this means take one data type, transform it into another, but we want to handle it in a certain way to handle these situations where we lose information. So this is a difference. Conversion means change the value, and cast means it's actually already the target data type. So we're finally getting into a position where we can create useful programs. And this time your task is to create an age calculator. So this is a program that is supposed to take in the user's birth year and output the age of the user. So think about what should be output and how to calculate this by using the methods you've learned in this chapter. So this has been a special task because you have to use operators here, and I haven't talked about operators specifically. But bear with me, I will walk you through a solution. So first we ask the user to enter his year in which he or she has been born in. Then we read in the user input as a string variable, and we convert this to an int. So this is a convert method as you've learned. And we have a birth year then. Next, I have a variable that stores the current year. So currently we have 2025. And here, this is a difficult part. We have to calculate the age without birthday. So in this case, we have to take the current year, which is 2025, subtract the birth year, and subtract one more year because the user hasn't had his birthday yet. And in case he's had his birthday, we have to add one to this variable. So this is done here, then stored in the age with birthday variable. And finally, I output this as your age is, age without birthday, or age with birthday. So let's press F5. And remember, you can always debug this program by adding breakpoints here. So now the program asks me to enter my year of birth in which I've been born. So I will enter, let's say, 2010. And it will output 14 or 15. So 15 in case I've had my birthday this year, and it's 14 in case I haven't had my birthday yet. So I want to show you one more thing. I'm currently in a command prompt in the conversions_exercise directory. There I've stored this solution. And we currently are writing only console programs, so we can use these on the command line. And to do this, let me show you the directory at first. So I'm going to write dir because I'm currently on a Windows system. But when you're on macOS or Linux, you simply type ls for list. And there I can see that we have this VS Code directory here. We have the bin directory, this CS project file, and our program.cs file. So this is basically the same as you've seen in VS Code, or what we have had open in VS Code. And when I type .NET run, I can run this program on the command line. So now our program is asking us for the year, and I can type 2010 again, and it will print your age is 14 or 15. So it's the same output, but now we've run this on the command line. So let's talk about operators. Operators are an extremely important concept in programming because they are everywhere. And in C# you have a lot of different types of operators. And they are so important because they are, as the name suggests, the actual doing. They are doing the actual operations, and this concept is formalized by operators. So when you use an operator, it's nothing else than performing an individual operation. So C# has a lot of operators. And the first category of operators that I want to show you are arithmetic operators. You already know these because you've used subtraction in the example exercise I gave you earlier when calculating the age of a user by him or her entering her birth year. So you already know that. And the other operators basically work the same. So the math that you used to know from early school, you can simply apply this in C#. You can add two variables or, for example, fixed numbers. Together you can divide numbers, you can multiply them. So this works out of the box and calculate new values. Next, we also have the pre, and postfix increment and decrement operators. So, for example, plus means add 1 to this variable. So when we write x plus plus, this means add 1 to x. And this is true for subtraction as well, if we say minus minus here. Next, we have assignment operators. So we've already used assignment, the first line here. When we write int x equals y, the assignment operator is used. And the assignment operator is basically taking the right-hand side and assigning this to the left-hand side, to the memory location of left-hand side. But you could also use the other operators here. So you could use plus equals, minus equals, etc., which basically means if we say x plus equals 1, this means take the value of x, but increment it by the right-hand side. So this could be also written as x equals x plus 1. And it's similar for all the other operators here. So minus equals is basically the same as multiply equals, etc. Then we also have comparison operators. So when we want to compare that a variable is, for example, less than 10, this can be done by the less than operator. Could also be less or equal than, which is the second line of this slide. You could also use equal operator if you want a variable to be precisely a specific value. So in this example, we have x equals 10. This means x, the value of x, should be equal to 10. We also have bigger or equal or bigger. And what's important for comparison operators here is that the result of this operator or this operation will be a bool. So this will either be true or false. So when x, for example, in this case is 10, in this example here, this means it's true. When it's not 10, so when x would be 9, for example, this would result in a false value. Next, we have the logical operators. So logical operators can, for example, combine these conditions. And for that, we have the exclamation mark, which means not. When we want to say, well, something might not be equal 10, we can combine the comparison with a logical not and have the final condition that we want to achieve. So this means not. We can also combine other conditional operators with and, which is done by the and symbol. And this is, for example, done in this example when we say x and b. This means this must be true and this must be true for the whole condition to become true. And finally, we also have or, which means either x or b or both must be true for this condition to become true. Finally, it's also important to understand the concepts of precedence, associativity, and other types of operators. But for this, I will skip to the Microsoft documentation because this is very detailed, and as a beginner, it will be hard to understand this fully. So I will show you the documentation briefly. I will show you or give you a link in the description. And yeah, I think the best way to understand this is by simply trying it out. So this is a C# operators and expressions documentation. Here you can find similar categories, as I've shown you. If you scroll down, we find the chapter about operator precedence. And let's take this expression as an example. So we haven't talked about var yet, but let's say this is an int. So imagine this as being int a, a new variable is assigned to the result of this calculation. So how could this be calculated? If you think about it, it could be either one of two things. It could either mean 2 plus 2 and then multiply the result with 2. Or it could be 2 times 2 and then add 2 to the result. So the result could either be 2 times 2 is 4 plus 2 is 6, or it could be 2 plus 2 is 4 times 2 is 8. So this is basically determined by operator precedence. So in this case, it's 6. And this means the operator multiply has a higher precedence. So it is executed, or the operation is executed first. So we multiply first. Then we add 2. So this addition has less precedence. So it's not as important as the multiplication. If you scroll down, you'll find the precedence of all operators in C#. So this is a huge list. Don't fall into the trap to research all of those yet, because there are many operators that you never need in practice. And if you ever need them, you can research them. And we will go over the most important ones in this tutorial. But here you can understand that, for example, assignment will be executed last, which makes sense because we always want to evaluate this right-hand side first and then assign to the left-hand side. Lastly, we have operator associativity. And this is a case when, or this is important when we have the same operator. So in this case, int a, this is determined by 13 divided by 5 divided by 2. So it's the same case basically, but operator precedence doesn't help here because we have the same operator. We have division and division. So what is executed first here? Well, the result is determined by the operator if it's either left associative. This means execute the left-hand side first, so 13 divided by 5. If it's right associative, this means execute the right-hand side first. So division is left associative, so this means, in this case, we will divide 13 by 5, which is basically 2, because we don't store the remainder, it's integer division. And next we divide by 2, which will be a result of 1. So I want to create a new project here in order to practice operators. So what I would do is I would create a new project to keep things separate. So I would type mkdir and I would call the directory operators, for example. But I want to show you another way. You can also type .NET new console, then you add a -n as an argument. And after that -n, we can add a name for the new console project. So I'm gonna call this operators. And now I have an operators directory fully set up with a C# console project. So when I type code with a period here, this will open in a new project and we basically have everything set up in a new directory. Great. So let's start with some Boolean operations. I'm gonna type, or let's say bool b. So we have an uninitialized bool variable here. And let's say we're gonna initialize this to false. When I output this, so let's say console.writeLine b, this result will be false, obviously, because we assigned false to b and then output b. So this will be false. But we could also say this is not false. So we apply the not operator, the exclamation mark, to the false here. And this result will be true. So this is negation. This means false becomes true, true becomes false. So the result will be true in this case. Let's press F5 and see if this works. So in this case, we have a true result. We can also combine this with more complex statements. So in this case, we have not false, which will become true. Then we combine this with an and we could also combine this with another true. Then the result will be true again, because this is Boolean algebra. So this will be not false, will be true. Then we combine this with an and another true. True and true becomes true. So this will be true as well. If we would combine this with a false here, this would be false, because this would be not false, which will be true. And we combine this with a false. So true and false becomes false, because an and combination or operator requires all of these terms, all of these operands to be true. And because this on the right hand side here is false, the result will be false. So if you want to dive more into this topic, this is Boolean algebra. And I can highly recommend you to check this out specifically if you have a lot to do with Booleans and a lot of conditions. We will dive more into this topic later in the course. So I want to remind you, in case you're stuck anywhere here in the course, you can always debug the code that I wrote or that you wrote. So to do that, you add a breakpoint here, press F5, as you know. And now the program stops here. So when we step over this line, we see that this result, so this has been evaluated by C# to false. So this means the result of this expression is false. But I want to show you also is that you have a debug console here where you can try out all statements that come to your mind, and C# will evaluate these statements for you. Or more precisely, not statements, but rather expressions. So when I type in false here, you can see that the result will be false. When I type in not false, not means negation, so the result should be true. We can see that this is in fact evaluated to true by C#. And here you can try out all of these statements that I've shown you. So when you say true and true, this will be true. But in case any of the operands are false, so false and true, for example, the result will be false. So in case you want to figure out details about the operations that I've shown you earlier, I highly recommend you to check it out and use the debug console here. Great. So let's stop this program and remove the breakpoint. Okay, so we've used bool literals. Literals means direct values like this false here. And we've combined those with logical operators like not or and. What is much more interesting in practice is to use, like, for example, an int x variable here and use comparison operators. So instead of using this false, I can type x less than 42. What will happen then is C# will evaluate this expression, which means evaluate the left-hand side of the and the right-hand side of the and. This is caused by operator precedence and will be evaluated last. The left-hand side, not false, will become true. The right-hand side, x less than 42, will become false. So in this case, true and false will become false. To get a true here, we could, for example, use less than or equal. Now this will be true because the left-hand side is true, and the right-hand side will be evaluated to true as well because less than or equal, in this case x is actually 42, this will become true because it's equal. To make things more clear, we can also use brackets here. So when you use brackets, you force C# to evaluate this part first. This doesn't make a difference because operator precedence says this will be evaluated first anyway. But it's important in this case to make it more readable. So whenever you think this is not readable without the brackets, go ahead and use these brackets. Okay, so let's do some arithmetic here. We can, for example, use plus, minus, division, or multiplication. So when we type times 2, this will of course be multiplied. The output will in this case be 84, and then this condition will become false. So you can see this here. You can also debug this, and basically arithmetic works as you've learned at school. So nothing special there, or no big surprises. The only thing that I want to note here again is that when you divide, so let's say we have another variable int y equals 5. Let's say I want to divide this by 2. So we can type division equals 2. This will divide the value by 2. Then we divide without the remainder. So in this case, we say C#, take this variable y, divide it by 2, and store the result in y. 5 divided by 2 will be 2.5, but it's still an int variable. So this is integer division, which means don't store the remainder, don't store the .5. The result will be 2.5, but the .5 will be omitted, and the result will be 2. So if you output this value, you can see that the result is, in fact, 2. So it's important to note this. So let's do something more useful. I want to create a program that calculates the area of a circle. So if you don't know, the area of a circle is calculated by r, the radius, squared, times pi. So let's delete this. First, we have to get the radius from the user. So let's get this by the console readline command. Sorry, string user input. Next, we have to convert this to a float variable, for example, or double. So let's say double. To double user input. Now we have the radius. Let's calculate the result. So it's better, instead of writing result here, we should rather use circle area, because this makes it clear what the content of the variable is actually. So in this case, I have to take radius times radius times. So this is not pi precisely, but it's close enough. And let's output this again. So in this case, I can type the area of the circle is. So let's try that out. So in this case, I can enter 3, for example, or let's say 3.5. And our program will calculate the area of the circle. Good. One thing to note here is that I've entered this plus to concatenate the string here with this double variable. And what I want you to be aware of, this plus here is also an operator. So this is nothing else. In this case, it takes a string and a double, and it returns a string. So this is nothing else than other operators, and in this case it does string concatenation. Okay, one last way to improve this further. Instead of using this double literal, so double literal means fixed double value here, what we can do is we can use predefined variables that are provided by C#. So pi is actually a mathematical constant, and C# is very polite and offers this to us. So instead of using this fixed literal here, we can type math.pi, which is when you hover over this, you can see it's a const double value, and it's much more precise than what I've entered earlier. So this would improve it further because now we are as close to pi as we can get. What I wanted to create is a calculator app. So the program should take in two numbers from the user, you add them together and output it back to the user. Similar to what the calculator app is doing on your phone, but just for two numbers. So let's have a look at my solution. First, we ask the user to enter the first number. We read that from the console into this string variable. Then I ask for the second number here. Then I convert both of these to double variables. And then I add both together and write the result with a console.writeLine. So one thing to note, this plus here, this means addition, because both of these are double variables. And in case of string, these would be string concatenation. So let's try this out. So I'm in this project directory. I'm gonna type .NET run. I'm gonna see two nullable errors, but I can ignore these for now. So I'm gonna type 10 and enter 20 as a second number. And the result will be 30. What won't work is invalid user input. So this has no validation yet. And this means in case we enter something weird like this, that cannot be converted to a double, then we will see that there is a system format exception. So there is an unhandled exception. Exception handling will be handled in a future lecture. So yeah, you don't have to care about this right now. We will deal with that later. If you want to get rid of that nullable exception for now, you can go into this CS project file and delete this line. So next I want to briefly talk about arrays. And arrays are actually much simpler when shown as an example. So let's dive right in. So what's an array? Imagine that you have to store 5 different int values. How would you do that? Well, you would probably do it like this. You would create 5 variables and store the values individually. So I named them x1 to x5 here, but this is how we learned it. But imagine now that we don't have to store 5 variables, but 500 variables or 500 values. Then we have a bigger problem because we have to assign each individual value to each individual variable or name in a separate line. So this will be very big. It will be very hard to keep track of which variable is which value exactly. And it will make the program very long and complicated. So this is not good. And on top of that, it could also be that we have to store a dynamic number of values. So that means maybe in the first run, our program has to store 5 values, but in the next run, we have to store 100 values. And this is where we get into problems if we use simple int variables anyway. So there must be a better way. And this is where arrays come in. So to declare an array, what we do is we type int, in this case, because I want to store int values in the array. Then I type curly square brackets, because this means it's an array. Then we name the array. So in this case, I name it XR. And then I assign it a new array. So in this case, I have to type new int, square brackets, and for example, 10. So this means this is an array of type integer named XR, and I initialize this to a new array of 10 possible values. So this 10 means you can store 10 different values in the array. So how do I use this now? So I could start by saying XR, which is the array. Then I type square brackets. And when I want to access a value, I have to type an index here. So in this case, we have 10 possible indices that we can use. So we can use the number 0 up to 9 because arrays are 0 indexed. So the first value is actually accessed by 0. So when I type in 0 here, we access the first element. And then I can assign a value to this array here. So let's say I want to store 42 in this memory location of the array in the first space, so to speak, in the first index. We can then, for example, store in the second one another value. And we can do this for all values of the array. So we can store 10 different values in here, up to the value 9, the index 9, for example. When we want to basically access the array element, we do it similar to how we used this in other places. For example, when we used variables. So in this case, I want to output the value of the array, but we can only output it when we access an individual element. So in this case, I want to output the element at index 1, which is the second element of the array. Let's execute this program. And the output is 10. So this means we store 10 at this element and we output the value. So let's briefly talk about the theory behind arrays, because it's important to have an abstract idea what arrays are when you're using them. So we've already talked about variables, like in this example, int x equals 42. This means we store 42 in a memory cell. And whenever we say x, we get an integer value back. And we refer to this memory cell as x. So one note here, whenever I say memory cell, I mean a chunk of memory. So if you would be very precise, a memory cell is actually 1 bit, 0 or 1. But what I refer to as memory cell in this tutorial is it's just a chunk of memory. Okay, but let's go over to arrays. So when we have an array, in this example I will use an int array again. So let's say we have an int square brackets x here. This means x is the name that we've referred to the array, and this is an integer array. And we initialize this array on the right hand side as new int square brackets 4, which means this is an array which has space or should be able to store 4 integers. So this here means 4 integers should be stored in this array. And this means an array will be allocated, which is 4 adjacent memory cells. And whenever we say x, we refer to this whole region of memory, so to speak. And whenever we initialize this array, this also means we set the memory to a default value. So in this case, we use 0 as a default value because we're talking about integer data types here. And this means every memory cell will be initialized to 0 here. So how do we use an array then? Similar to what I've shown you earlier. We use an array by saying, for example, x, and then we type an index in the square bracket. So that's just a number. And we begin with counting from 0. So 0 is basically the first memory location. So saying x square bracket 0 means give me the entry of the first integer of this array. And when we, for example, say x1 equals 42, we say, please assign 42 to the first, or in this case, it's actually, because we are 0 indexed, it's the second index, to the second memory cell. So this means store 42 in this second memory cell. So that's basically it behind arrays. It's not that complicated, but when you have to keep track of indices in practice, it can get complicated. So you have to know how big the array is and that you're working with different indices. But we'll get into that later when we talk about control flow. Okay, so I'm back here at my program, and I want to show you another way of initializing arrays. So let's get rid of this and this here. So I'm left with the XR array, and this means initialize 10 values, initialize an array with 10 values so that we can store inside the array. But instead of saying initialize it here and then basically assigning values down here, so for example assigning, I don't know, 1 to the first value, we can instead, well, let's make this more clear. Let's say I want to store maybe 1 in the 0 index in the first element of the array, and 2 in the second, 3 in the third element, etc. What we can do instead is we can use array initialization, which requires these curly brackets here, and I can simply type the initialized value. So when I say 1, 2, 3, 4, 5, let's say just 1, 2, 3, then this is the same result as assigning these values down here in individual statements. So when I do a system.console.writeLine, don't require system here, and output the first value here, the result will be 1, of course, because this sets the first value of the array to 1, the second value to 2, and the third value to 3. So it's basically the same as assigning these values individually down here, and so on. So this is a fast way to initialize arrays, which you should obviously use because it's much more clear what this will be, what the result will be in this array. So yeah, it is much more precise to do it this way. So just for the sake of completeness, here's an example of using an array of a more complex type. So in this case, I have an array of strings. It's called names, and I initialize these to 3 name values, John, Mickey, and Jane. And then I output the first element, the second element, and the third element. So when I output this, you will see that all of the names are output. And let's say I want to replace the second name, then I would type names. I have to enter 1 here in the index, in the square brackets, because it's, as again, 0 indexed. This means 0 is the first value, 1 is the second. Let's say in this case I want to replace this with Will. And when I output all of the names again, first the result is John, Mickey, Jane, and then we have John, Will, Jane. So we've replaced Mickey with Will. As an exercise for arrays, I wanted to allocate a dynamically sized array. So dynamic in computer programming means at runtime. So this means when the program is actually run and not predefined. And for example, dynamically sized, you could get the user input, and depending on the number that the user enters, you can then allocate a different array size. So please try that out. So this is my solution for the array exercise. First, we ask the user to enter an array size. Then, as you know, we get the user input by console.readLine command. Then we convert this input, that is a string, to an integer, and we call this array size. Next, we allocate an array of type int, and then we allocate this dynamically. So here we don't have a fixed size, but we allocate an array sized length array. And finally, I output the length of the array to make sure that the array is in fact that long. So length of the array, if you type array.length, this outputs the number of elements that we can store in the array. So when I press F5, I can say, well, I want to get an array of size 200. And in fact, we have allocated an array of 200 integers. But when I press this again and the runtime input changes, so let's say I want an array of size 5, we only get an array of size 5. So this array has been allocated dynamically. So you've learned about strings, which are text. You've learned about individual characters, and you've learned about arrays, which are basically, a combination of individual fields of a given type. And the interesting part here is that strings in C# behave like arrays. So you can use a string similar to how you can use an array of chars. And in this exercise, what I want you to do is get the user input and print the first and the last character of the input. So this is my solution. First, I get the user input by a console.readLine method call. This is a user input as a string variable then. And in order to get the characters, I told you that strings can be treated like an array of characters. And to get the first element of an array, you have to use 0 in square brackets. This is what I do here, because arrays are 0 indexed, or the index is 0 based. So this would be the first character. When I want to use or get the last character, I have to do this depending on the length of the array, or string in this case. So I have to type user input.length. And because it's 0 based or 0 indexed, I have to subtract 1 here. So in case you have an input of, for example, 2 characters, length would be 2, and then we subtract 1 because we want to access the second element. So this would be 1, which is the access of the second element of the array. And finally, we output these values down here. Let's try this out. So let's enter hello here. And the output will be the first character is an H and the last character is an O, as we expected. So next we're going to deal with control flow. Control flow means we adjust the program flow depending on the circumstances. And the first thing you have to know about control flow is how to use an if statement. With if statements, we can finally change the control flow of our program. So what we can do is we can, based on certain conditions and bool variables that you've already learned about, we can finally do special actions. So instead of simply typing the value of this or printing the value of these conditions, we can do some special action depending on the value of these bool variables. So in a way, we get enabled to react to the environment or the circumstances that our program is running in. So let's make this more clear by an artificial example. So let's say we have a small program that allows a user to enter, or user could also get rejected by the program, based on his or her age. So let's say we have a club, and when a user is older than 21 years, he or she is allowed to enter the club. So how would we do that? Well, we would start by asking for the user's name. Then we would convert this into an integer variable called age, because we need this as a whole number. Next, we have to transform this to a condition, to a bool variable, and check if the user is greater than or equal to 21 years. So when the age is greater or equal to 21, he or she is old enough. And this is stored in an over 21 bool variable. So this will be either true or false. So how do we use this now with an if statement? Well, if statements are not that complicated. The structure is as follows. So you start by typing an if, then you have this parenthesis here with a condition inside. So in this case, it's the simple bool variable, simple bool result. And then you have these curly braces. And the code that is written in these curly braces is basically executed, but only when this condition or bool variable is true. So in the case, when this is true, C# will execute this code. So let's try this out. So let's say I'm 21 years old. Then the program writes you're allowed to enter the club. So this line here, this will be executed. But when I say I'm only 20 years old, so let's try this out, then nothing is output here. So this line is basically, or this block, everything that is written inside of these curly braces, so this could be multiple lines, is skipped. So this is how, basically the basic structure of an if statement is executed and how it looks like in C#. Good. So let's say I want to also output something when the user is not allowed to enter the club, because currently the program is quite rude. Doesn't give you an answer when you're not older or when you're not older than 20 years. So in this case, it's pretty much not reacting to us. So we can do this by using an if-else statement. So I'm going to type else here and add another block of curly braces. And what's happening now is when this condition or this bool variable here over 21 is true, then the first section, the first block is executed. But in case it's false, the else block here, this down here, is executed. So let's say we output you're not allowed to enter the club here. So in this case, we at least tell the user, hey, sorry, but you're not old enough. So let's try this out. So let's say 20 years again, 20 years old. And now you can see that we output you're not allowed to enter the club. So this block has been executed, but not this block. And in case I'm old enough, let's run this again. Let's say I'm 21. Now I'm old enough, so only the first block is executed. Only the first you're allowed to enter the club console.write line is executed here. Good. So we can also do more complex expressions or more complex conditions. So we might want to react differently depending on more than one basic condition. So let's say our club offers a discount in case it's your birthday. So we want to do this also in our program, of course. So I'm not going to get some user input this time. I'm going to make it simple. And let's say I have a variable called isBirthday. And I'm going to store a false value in this variable for now. So in a real program, you would, of course, use the user's input here. And, well, the whole example is pretty artificial, of course. But in a real program, you, of course, need to get this value from somewhere. So let's say when you're over 21 and when it's your birthday, when both of these conditions are true, then we want to output a special discount to the user. So I could do this by saying, when you're over 21, and we combine these two bool variables into a single variable with an and, and both of these are true, then we output there's a special 10% discount for you. Good. So let's try this out. So obviously I'm not gonna have a birthday today. So this is false. Let's say I'm 21 years old, and no, the result is not what we have expected here. So as you can see, we're not allowed to enter the club. Why is that? Well, this is the condition, and the whole condition must become true for this block to be executed. And because we don't have birthday today, this else block is executed. So we have to make sure that in case we're still over 21 years old, we don't have this special discount, but we're allowed to enter the club. So let's do this, and we can do this by an if-else block. So we can say down here, else if, of course, else if over 21. Then we need the curly braces. Gonna paste this line here. And now we have an if else block. So you can basically use as many else if statements as you want. But what this is doing is, if the first condition is true, the first block is executed. However, if this is false, we're gonna evaluate the next condition and then do basically what's inside this block. And when this is still not true, we could execute even more else if blocks. Or finally, if all of these conditions are false, we're gonna output this else block, or execute what's inside this else block. So let's try this again. Let's say I'm 21 years old. Now we're allowed to enter the club. In case we have birthday. We get the 10% discount here. Great. So this is how you can use if and else if and only else blocks finally here down here in order to change the flow of your program and execute only parts of these programs. We can also call these blocks depending on a condition. So these conditions here, they can be as complex as you want. You could do any condition combinations or logical operators that I've told you. You could use or blocks, not blocks, or not operators in here. And we could still use these results. But as you've seen, it's quite hard, or it can get difficult to really understand what your program is doing. So you really have to consider all of these conditions and make sure that the logic that you're programming here is doing the thing that you actually want to do. One note regarding control flow statements in general. So when we get into more and more control flow statements, there are many more ways than just one way to do things. So that means in C#, but also in basically any other programming language out there, you can have different programs that have a different structure but behave the same. So to phrase it another way, to solve a specific problem in one programming language, you still have a lot of different options how to do this and how to structure your program. To make this precise here, this special discount is only executed when this condition is met here. this line here, which could be, for example, a complete subsection of a program. So you could imagine that this entering the club could be a lot of statements. This is duplicated down here. So we could also restructure the program to say when both of these here are true, we output the special discount first, delete these here, and the else block. So what this would do is we now have an if block and an if else block. The if block is executed up here when the user is allowed to enter the club, and when it's his or her birthday, then we write down the special discount. And finally, when he or she is over 21 years, then we also allow him or her to enter the club. So both of these conditions are used, or both of these Boolean variables are used in the condition of the first and the second block. So this would finally result in the same output or in the same behavior of a program. So when you check this, so I'm currently having my birthday because the variable up here is true. And when I'm 21, this block is executed, but also this block is executed. And when I'm not over 20, so let's say I'm 20 years old, I'm not allowed to enter the club. Why? Because I'm not over 21, so this variable will be false, which means we skip this block here, this one, and we also skip this block, and we only execute the else block. So again, if you are unfamiliar with how C# executes this, or if you want to have a deeper look here, you can always do this breakpoint and debug the program step by step. So please go ahead and pause the video in order to better understand what's going on here. So you've already created a calculator app that adds two numbers together. This time I want you to ask the user whether he wants to add or subtract the numbers that the user has entered. And for simplicity, we're gonna use integers this time. So this is one solution. First, I ask the user to enter an integer. Then I do a console.readLine. And instead of storing the user input as a separate string variable, I directly convert this to an integer. So this is a nested call. First, console.readLine will be executed, and then it will be directly converted to an integer. So this is the first operand. I do the same for the second operand. And finally, I ask the user to enter a plus or a minus. This is stored in the op variable for operator. Now we have the if else block. So first, I get the first entry of the op variable. So this is basically plus or minus. And because it's a string, we can access the first element with a 0 here. So when this is a plus, I execute the plus operation and write the result to the console. When this is a minus, I do the same. So I do this with a minus operation. So here's a minus. And finally, when nothing of these two blocks, so none of these two blocks has been executed, neither the plus nor the minus, the else blocks will be executed, which says invalid operator, because then we couldn't translate this to an operator. So let's try this out. So let's say 20, 10, plus. So the result will be 30. And let's do this again. Let's say 20, 10, minus. So this is 10. 20 minus 10 is 10. Good. So one thing, I've used this OP variable here for operator. This isn't good because, well, OP could be anything. It's just 2 letters. So it's much better to use operator as a name here. I couldn't do this because C# has an operator keyword. So this would interfere with C#, thinking I will now type a keyword here. However, when I rename this, so when I hover over this, or I have this OP selected here, and press F2, I can rename this operator. And this means we have an @ sign in front of this variable. So this isn't strictly necessary, or it basically isn't necessary at all for other names. But when the name is operator, it's a keyword, then we need to use this @ sign to specifically tell C#, hey, this is an operator. This is not an operator, this is a variable named operator and not the keyword operator. So the same when you say, for example, this would be named string, for example. So let's rename this to string just for comparison. So this will still use an @ sign. If you only called it S, you wouldn't need this @ sign. Okay. So a switch statement is very similar to if-else statements. So instead of writing a ton of if-else statements, switch statements are rather used when you have a lot of different options, so to speak. So the default or standard case where you would use them is when you have a limited set of options or enumerations that you can use. And I try to simulate this here. So let's say the user can select one of 3 options. Then we could use a switch statement. So this is done by typing switch. Then the variable that we want to switch on. So user option. Next, what I would have to do is, so usually I want to have this curly braces in a new line. Now what I can do is I can say case. Let's say case 1. And let's 1 break. So what this is doing is it's saying switch to a switch statement on the user option, which is an integer in this case. Then when it's case 1, execute this block below until you hit a breakpoint. So, it's not a breakpoint, it's rather a break statement. And then we leave this switch expression. So let's say we have another option called 2. Copy this. So now we have option 2, and we can do the same for option 3. So this is a basic layout of a switch statement. So let's try this out. So in this case, we have user option 1, which basically only prints the first console.write line until we hit this breakpoint here, or this break statement. Let's say we have 2, press F5 again. Now we can see it's option 2. And the same would be true for 3. But what would happen when I enter, or I have a user that selects 4? Well, in this case, nothing will be executed because no option is valid here. So what would happen in this case is that we would need a default branch here. So we could add default and we could say no valid option selected, for example. And we don't have to forget to use these break statements here. So let's try it again. And in this case, no valid option is selected. So this is very important. You usually always want to have this default branch in your code when you use a switch statement, because when you don't basically have a case statement for all options and you're not 100% sure that all options are covered, you need to understand, or you need to specify what should happen when none of these options are valid up here. So one question you might have is, why would you use or why do you have to use these break statements here? Well, you have to put them here because you could also basically combine these statements instead of without a break, so to speak. So let's make that more clear. So what would happen in this case when I delete it? C# would say cannot fall through from one case label to another, but we could do it like this. So we could say when we have case 1 and case 2, in both cases, please select this option 2. So this would be valid. And even if you select option 1, obviously this code would be executed. So it's possible to combine multiple cases until it hits a break here. So this is one reason why you need this break statement down here. So I would like to show you an example when I would myself consider a switch statement in practice. So imagine this being a measurement value from a sensor. Let's imagine this is a sensor from a water boiler, and this would be obtained from the sensor directly. So in this program, I would like to act on this value, and depending on the value, I would want to branch into different branches of my software, basically. So I would want to do different actions based on this value. And as you can see, there are a lot of branches available. So first, I have an if statement when this is less than 0, because it's a Kelvin measurement, or bigger than this value. This is not in a valid range because the water cannot be hotter than steam in this boiler. So let me put a space here. Perfect. And when this is not a number, so double can have a not a number value. This is a special value for double. This means the measurement has failed. Next, we also have the possibility to be less than this 273.15. This means the water is frozen. So for all of these branches, imagine that this is not only one console.writeline here, but we would do a lot of actions depending on this value. So when the water is frozen, we would basically turn the boiler off because it could damage the boiler, for example. And you can read yourself. So in this case, the water would be liquid, and in this case, water turns into steam. So this sounds valid at first. And now I want to show you how this would look like when we would use a switch statement. Because why would I consider a switch statement here? Well, simple, because we have a lot of branches, a lot of blocks of code that should be executed depending on one variable. So only one of these should usually be executed, one of those blocks, but all depend on one variable, and we have a lot of cases. So this should ring a bell in your head that you should consider a switch statement here. So a switch statement, let me put that space back here, would look like this. We would start with switch measurement. Next, we would have a case statement here. When this is not a number, we would type measurement failed. We would add a break here, break statement. Next, we would have less than 273, bigger than 272, etc. So one thing that would be better in this case, why you should consider a switch statement, is that you can see here, this shows an error. Why would this be an error? Well, because when you do it in a switch statement, C# knows all of these conditions depend only on this measurement variable. And it knows that this, because it analyzed our code, it knows that this is unreachable, because when the value, when water is liquid in this case, when we are above this value, this will already have been executed. So in this case, we could not see the error. At least maybe you've spotted it, but in a real program, it usually gets quite hard to see all these errors. And here, this would have been executed if we would have a value like 373, for example, like this value. if measurement would have been 373.15, this would be above this value. So this block would have been executed and not this block. So this is important. And this, we would have only spotted this when we executed a program with this specific value. But in this case, we can see that C# spotted the mistake. So the compiler told us, well, this is not a good idea here. So what we would have to do is we would have to move this more upwards here, because C# goes from top to bottom into these statements, and now this is reachable. So this, in case it's this specific value, this console.writeLine statement will be executed. What we need here again is a default value. So yeah, in case we have this default value, we would copy this line. Yeah. And in this case, C# is actually smart enough to understand that this will never be executed. So yeah, even with this default statement, we see that C# knows, well, all of the possible values are executed up here. So we would even be advised by the compiler here to say, well, yeah, C# tells us, no, remove this code, it's not necessary. So this is a good example to see that switch statements can be helpful. And if you look at this code, this is also quite readable compared to this code. So in this case, I would really consider this switch statement to be a much better option. For the switch exercise, I want you to extend the calculator app and also offer division and multiplication to the user. So please do that. And instead of using a lot of if, else, I want you to do this in a switch statement. So here's my solution. You probably remember these 4 lines up here, where we get the user input, the first operand and the second operand as an integer. Next, I ask the user regarding the operator, so plus, minus, asterisk, or slash. So this is multiplication or division. Next, I get the operator by a console.readLine command. So you probably remember, but we have to put this add here. So this is needed because operator is a reserved keyword, and the add tells C#, hey, this operator, this is just a variable name. This is why we have to put the add inside of this variable name here. Next, I declare a result variable, an integer. Then we do the calculation. So I do this by using a switch statement, and I switch on this add operator variable, but only on the first element. So because operator is a string variable, we can access this like an array, and I access the first element, which is the first character. So in case this is a plus, I calculate the result as a plus. In case it's a minus, I do this as a minus, etc. We always have this break statements here because we will need to leave the switch statement afterwards. Finally, there's a default branch. So this default here, this is needed because if none of these have been hit, the user has basically selected an invalid operator. So you're probably wondering about this return here. What does this do? Well, return is a jump statement similar to break, but instead of break, which just leaves this block of code here, a return statement leaves the function, or in C# rather a method. So this would leave the method. We're in this whole block of code, we are always in the main method. So this would in effect basically return the whole program. So it would stop execution. And finally, I output this result here. So I will talk about return later, but if you're wondering, how could I solve this without a return? Well, you could simply copy this line and output the result up here after each of these calculations. And then you could use a break instead of a return here. So this would work as well. So the next control flow statement is a while loop. Compared to previous control flow statements, that is switch and if statements that we've talked about, there we've just decided to basically branch of our code. So that means execute additional C# program statements depending on the condition. So when the condition was true, we have done some extra code. When it was false, for example, we might decide to use an else branch and do something different. It's different with while loops, however. So while loops basically mean execute some code until the condition is not true anymore. So while the condition is true, execute the code again and again. So let me show you that. Here you can see that this is a countdown. So C# is counting down a number. We start by initializing this number from 10. Next, this is a while statement here. So this here is a while statement. We start with a while. Next, we have these parentheses. And inside of here, we have a condition. And that means execute the following block of code until this condition becomes false. So when this condition is true, to state it in another way, when this statement or condition here is true, execute the following block again. So this is a block of code that we want to execute again and again. So this time I want to output some empty line. I would like to output the actual number. Then I decrease number by 1, number minus minus, and then the condition will be evaluated again. And when we're done, then we write, well, time is up, because this is supposed to simulate some sort of timer here. So let me show you that. Let me add the configuration and press F5 again. So here you can see we've executed this while statement, this block of the while loop 10 times. We've executed with 10, we've executed with 9, 8, 7, etc. So if you want to understand this more or in depth, how this is executed, we can do this by setting a breakpoint here, pressing F5, and we can step over all of these lines here. So we can press F10 to go to the next line. So here we can see C# evaluates this condition. Number has a value of 10. It's bigger than 0, of course. So we will execute the while block of code this here one time again. So we will execute this, output the number 10, decrease number by 1. So number is 9. And now the condition will be evaluated again. So 9 is still bigger than 0. We go into the loop again. Now we're at 8, and so on. So let me put a breakpoint here. Let me press F5. So when we hit this line, number has decreased to 0. So the last time when all of these, when the block of code has been executed 10 times, number has been decreased to 0. That makes this condition false. And that basically says leave this while loop. So this tells C# this will be skipped next time, or this will be skipped now, and we move on to the next line of code. It's your task now to figure out what happens when we forget to program the action that causes the condition to become false at a certain point in time. So in this case, the number minus minus. So what is the action that causes the condition to become false at a certain point in time? Well, here we decreased the number variable. And that means at a certain point in time, number will become less than or equal to 0. So this condition here, this while condition, will become false at a certain point in time, which causes this loop to break, and which means the next statement will be executed. If you forget this statement, then, well, what will happen? Let me show you. So let's move into this directory and let's output .NET run. What you can see here is C# outputting 10 and 10 and 10 and 10 and 10 and so on. So it's constantly outputting 10 and it never stops. So let's use Control C here to stop the program. And what you should learn with this example is that there is no built-in, or there is no mechanisms that stops you from doing this type of mistakes. So you always need a statement that makes sure that this condition will be false at a certain point in time. Otherwise, your program will be stuck in this section of your code forever. So whenever you use a while loop, you have to think about this. So next we have the do while statement. The do while statement is basically a while statement, but instead of evaluating the condition first, we evaluate the block of code first. So what do I mean by this? Let me show you that a while statement evaluates the condition first. So let's say we have a number and the number is 0. So let's output number here. So this is similar to the last section. But the difference is that we initialize number to 0. So if you think about this, number will never be bigger than 0. So what would happen here? Well, C# will never actually execute this block of code. So when I run this, you will see that only finished is output here. So the difference is that when I say do while, so I can move this down, then I have to put a semicolon here, and I have to put a do here. This is a do while statement. This will always evaluate this block of code at least once. Let me put this curly bracket on a new line. So this will be executed once, and then we check the condition. And if the condition is true, we execute the loop again. So in this case, you can see that 0 is actually output and finished is output afterwards. So we do execute the loop at least once before evaluating a condition. You're probably wondering, when should you use a do while statement versus a normal while statement? Well, the answer is, in practice, you'll almost always encounter while statements. However, there are occasions when you should use a do while statement, specifically when you need to execute the code block first. So let me show you an example. In our previous tutorials, or in our previous chapters, we always got the user input, but we never actually checked if the user input is of the correct data type. So when we got an integer from the user, we never checked that this is actually a real integer, and our program would usually crash if it's not. So let's fix this. So let's declare a user input variable up here. Let's ask the user for a number. And let's say user input equals console.readLine. So here I'm gonna get the user input. I'm gonna show you a new method now that checks if we can actually parse this user input as a number. So this means if the user input as a string is actually only a whole number. So we can convert it to a whole number. So to do this, we type int try parse. Then we have to put the user input in here. And we have to pass a specific parameter that we don't have to care about here. So don't care about this. It's not important right now. But this method here, we can enter the string and it will tell us, hey, is this parsable? So that means, can we convert this string to an integer? So in this case, we would actually repeat the loop when it is convertible. But we don't want to do this. We want to repeat the user input when we cannot parse this. So we have to put a not in here. So this means if we cannot convert this user input to a number, please repeat, please do the loop and ask for another input. So we'll get a new user input and the user input will be checked if we can parse this. So afterwards, we can say, convert this to a real number. And we can output this here. So let's try this out. So let's say I'm gonna enter ABC. This means it's not parsable. So the loop will be repeated. Because not parsable means this whole expression will become true. This means the loop will be repeated. So let's say we're gonna enter 42 ABC, which is still no valid integer. So we'll be asked again. And let's say we're now entering only 10. So in this case, this is parsable. So this means we're gonna exit the loop. We're gonna get to this line, convert it to a number, and this is the output then in this line. The next important control flow statement is a for loop. And in order to understand a for loop, I'm going to show you an example with a while loop first. So in this example, I want to output all elements of an array. In this case, it's called numbers. It's an int array, as you can see here. And I've initialized this array to the values 1, 2, 3. So how do we output all elements of this array? We start with an index variable that's usually called I, and I initialize this to 0 because arrays are 0 indexed, so the first element is accessed with 0 index. Next, I start the while loop, and I'm going to execute this while loop whenever the index is less than the numbers.length. So this is important because when index becomes equal to numbers.length or bigger, we're outside the range of the array. So we cannot access that anymore. That's because arrays are 0 indexed. So this will be index number 0. This will be index number 1. And this will be index number 2. And for each iteration here, we're gonna output the numbers value at I and increase the index by 1. So let's execute this. Now let's do that again. I think there was some mistake here. Yeah. So the output was truncated weird in the first example, but now you can see this worked fine. 1, 2, 3. So what we do in programming very often when we have an array is that we do basically the same thing here. So we iterate over the whole array. So this is in fact so common that there is an own construct for this, and that is the for loop. So you don't have to iterate over arrays with a for loop, but it's a very common use case. So let me show you the syntax. So for loop is started by typing for, then we have these parentheses, and in here we have 3 parts. The first part will be the initialization. So here I usually say int I equals 0, for example. So this is the upper part here, and this will be executed once. Next, I have the condition. So this is similar to a while condition here, where I say I less than numbers dot length and semicolon, because this will separate the third part here. And here I'm gonna have this last statement that's executed after every iteration of the while loop or of the for loop. So after every code block, this will be executed. And now I have the basically block of code that's executed for each iteration. And in this case, this is just a console.writeLine I. Sorry, numbers at index I. Because we want to output the value of the array at that index. So here you can see that this is basically already defined. So I'm going to get rid of this to get rid of this error. But this is basically the same thing. So this is absolutely equal to this. And in fact, the for loop is just a neat way to write this in a more readable format. So in the for loop, this is executed once as the initialization step. Next, this is a condition that is executed during each iteration to check if we have to exit the loop. And this will be executed after every loop or after every iteration of the loop. So let's try this. And as you can see, we have the same output here. To understand for loops better, I want you to create a multiplication table. So that means the user should input a whole number and you output every multiplication of that number with 1 up to 10. So pretty simple if you understood for loops, but please go ahead and create that. So here's my solution. First, we get a whole number from the end user. Next, I'm going to output a title line that this is a multiplication table. And here I'm going to output the actual table. So I start by initializing this counting variable to 1. So this will be executed once. Next, we're going to execute this loop when we are less than or equal to 10 with this variable. And I increase the variable by 1 in each iteration here. So this will output, this line here will output the actual table line by line. And each line is basically written as the number variable that the user has input. This X that represents the multiplication operation as a string when I output this table. The counting variable that is increased by 1 during each loop iteration, an equal sign, and the actual multiplication. So let's try this. And let's enter 5. And as you can see, here I output the multiplication table for 5 and all of the possible values when I multiply 5 with 1 to 10. Welcome to this last section of our control flow chapter. Here I'm going to talk about some control flow specifics that you'll encounter in practice. And we'll start by talking about the break statement again. We've already encountered the break statement before, if you remember the switch statements. There, we needed to break out of the switch statement when a certain case was met. So what do I mean by that? Well, let's say you have a switch statement and the user has input some condition that we checked with this case statement. Then we had to break out of this code after we've executed the specifics. And the same is true for break in general. So we can use break with while loops and for loops and do while loops as well. And what this will do is it will break out of the loop. So it will stop the iteration. And I'm going to show you that with an example here. In this example, what we're going to do is we're going to do the same as we did with the do while loop. We're going to ask the user for a valid integer. But if you remember the do while loop example, there we've only asked the user for an integer and never actually made sure that we told him that he made an error when entering his integer. So that was not very user-friendly because the user couldn't know what he did wrong. So let's show you this by an example. So here I ask the user for an integer. Next I declare this string user input here. And here we have a surprise. We have this while loop and a true condition. So this means while loop will execute again and again, and it will actually never stop executing, at least based on this condition, because this will always be true. So this code here will execute again and again. Next, we have this user input that is received by the console.readline method. Here I'm gonna repeat this and check if the input is actually parsable. So that means when the user input can be parsed as an int, which means it's actually convertible to an int, then we execute this break statement. So that means break here will break out of this while loop and stop the loop. So it will stop iterating again and again. So this is how we will stop and make sure that this while loop will not execute forever. So one note here again about this if block. We've always used curly braces here after the if block, and that is not strictly necessary. So when you only have one statement that should execute after the if block, like this break here, you can omit the curly braces, and you can only type this here. In practice, I recommend you to always use these curly braces here, but I want you to understand that this is not strictly necessary because you'll encounter this type of code in practice as well. But yeah, I would recommend you to always use these braces around the next statement that you want to execute. So this will execute when the if condition is true. And if it's not true, we will say, hey, user, this is an invalid number, please try again. And when we've basically left this user input here, or when we've left this while loop here, then this try parse was successful, which means we can actually convert this to an integer. So let's try this. So when I say A, now we have a real error message that is shown to the user. And I say B, we also have an error message. And I say 42. Then this was parsed as a valid integer. Great. So next I want to talk about continue, which is a similar statement, but instead of breaking out of the whole loop here, it will say stop this iteration and continue with the next iteration. So let me show you an example here. In this case, when it's a double, so we have a real number in this case. When this is parsable, it's similar to this int try parse method here. We don't have to care about this again. What I want to do is I want to show a different error message instead, invalid number, because when this is a double, this means the user has entered a real number and not an integer. And I want to have a specific error message for this. So in this case, I write, hey, this is a real number. Please try again. So let's say, and enter an integer. But when I execute this code, I don't want to execute this other error message here. So I don't want to write that out to the user because I've already told him that this is a real number. So in this case, I'm going to hit this continue statement, which basically says, hey, repeat this whole while loop again. So we will start at the top again. So let me show you that. So when I enter A, this will be false. And we're going to hit this console.writeLine. But when I enter a real number, this is, so here you can see when I hover over it, this is a real number, please try again. So in this case, we've executed this. We have hit the continue statement, which starts a loop again up at the top here. So we don't hit what's below this continue statement. So let me show you that again. So here it's a real number again. When I enter a valid integer like 10, Then I'm gonna still break out of this loop, and I'm gonna hit the code below here. So in this case, we've used break and continue to output some very good error messages to the user. And one last thing about scopes. So when you program, you will encounter the word scope a lot, and I want to show you what scope means. So whenever you have this curly braces, this block scopes, this code blocks here, you have a different scope. So that means whatever you define in here will not be accessible outside of this block. So this is the reason why we have to, let me scroll down. This is the reason why we have to declare this user input actually up here. Because if I don't do this up here, and I would declare it here, we would encounter the errors that said this is in a local scope in this while loop. So this is what scope refers. The code block where this variable is accessible. And this curly bracket would be a new scope. This would mean the user input would not be accessible down here because it's outside of these curly brackets here. So this is why scopes are important, and we're going to talk about scopes again when we talk about methods. And this is also the reason why we have to use this string user input up here. Because now it will be in this whole, in this block, it will be accessible after the declaration. So it will be accessible down here. And this means we can use it up here or down here. So the final control flow exercise will be to build a guessing game. So please go ahead and ask the user for a magic number. And this magic number is predefined between 1 and 100. And whenever the user has guessed too high or too low, you tell him that until the user actually hit the magic number. And you count the user inputs, how long it took him to, how many guesses it took him to find the magic number. So let's go over my solution. First, I declare the magic number. Then I declare an additional variable. This int, number of guesses, counts the number of guesses that the user required in order to find the magic number. Next, we have a while true loop. So this loop iterates again and again until we hit a breakpoint. So this block here. You probably find this code here familiar, because here we declare the user input and we ask the user again and again until his input a valid integer. This is stored in the guess variable. Next, I increase the number of guesses by 1 with number of guesses plus plus. If the user has guessed too low, then I output this in the console and I continue with the next iteration. So the user has to input another guess. So we start at the top again. If the user has guessed too high, I output this as well and continue the same loop. So we continue at the top again. And finally, when the user has found the correct guess, when the guess is the magic number, then I output congratulations and we break out of the loop. And finally, I output the number of guesses that the user required in order to find the magic number. So let's try this. Let's simulate some user input here. So let's guess 10. So that's too low. Let's guess 60. That's too high. Let's guess 30. Maybe 45. And let's say now we have the correct number. And it took us 5 guesses. So that's cool. And one note here. We could improve this code further, or depending on how you view it, but I would say it's improved if we get rid of this statement here, this if block. Because when the magic number is not less than, or the guess is not less than the magic number, and not bigger than the magic number, because in both cases, we continue the while loop up here, which means we will only reach this block of code down here when we've actually found the correct magic number, because otherwise we will hit this continue or this continue. So we could simplify this further by removing this code and this code. So let me show you that again. So let's simulate the user again. So in this case, we found it with 4 guesses. So the Visual Studio Code output is basically a little confused here, but don't mind, it's still working as expected. So let's do that again. So here you can see it works as expected. In the past tutorial, we have repeated code again and again. For example, the code for getting an integer from the user in a console application. However, as our code base grows, this becomes less and less feasible in practice, so there must be a way to reduce code duplication. And this is where methods come in. So this is a code I've talked about. We have used this plenty of times. It's for getting the user input as an integer. And it's basically doing this in a console program. So we ask the user again and again until he is inserted a valid integer, and then we convert it to an integer here. So let's imagine you don't have to use 1 integer, but you require 2 or 3 integers from the user. So you'd have to basically copy this program, maybe get rid of this, get rid of this. Next you would declare an result2 variable, result3 here, get rid of this part. So as you can see, now we get 3 different integers, but it's increasingly complex to look at this and understand what's going on. So next it would maybe also make sense to ask for a double in this case. So we would have some minor changes here. Maybe we would change this question at this point, but maybe we forget it here. So let's say we say whole number here, then we would have to repeat this part here and here. And if we forget to repeat this part, well, our program becomes inconsistent. So it's basically not a good idea to do it this way and repeat the code again and again. Instead, we should use methods. So let me get rid of this. Now let's comment this out. Let's talk about a method. So the structure of a method starts with first a data type. So this could be int, double, string, as you know. Next we use a method name. Then we have a starting and closing parenthesis. In here we can declare different parameters that we use in the method. And after that, so for example, data type parameter 1. And next we can have this curly braces here, which basically is the method body, so the code that should execute. We could also declare multiple parameters, so we could also have maybe another data type here and say parameter 2. As many as we want, basically. So let's make this more clear by having a concrete example. So let's say I want a very stupid method that returns an integer, and let's say get 42. We don't need a parameter for this, and in here I just type return 42. So what this is doing is it's saying this data type will be returned. So the method will return an integer. It's called get42. We don't have parameters here, and the method is only returning a number. So that means I can use this in my program here. I could type int my number, and now I could say get 42, for example. So this method will be called in this place here, and the return value 42 will be returned, and this will be allocated or assigned to this variable. So let's output my number, and let's press 5. And as you can see, we have 42. So let's debug this for a second. So let's put a breakpoint here and here. Let's press F5 again. So when I'm at this stage, what happens is I can basically say step into, and this will basically be a call, a method call, which says jump into this method. This method here, I'm just returning a number, so no real action, I'm just returning a new number, 42. So when I leave this method, I'm back up here, and this 42 will be the result because it's been returned here, and it will be assigned to this variable. So what we can do now is we could basically reuse this method. So instead of having this method only being called once, we could reuse this in multiple places. So we could say, for example, we have 3 numbers, and in any case, this is defined by this method here. So when we change it in this place, so it doesn't make sense because it's called get42 in this case, and we return 43. But I think you get the point that we've only changed it in one place, and it will change all of these results here. So when I press F5, you can see it's 43 now. So let's make a method that actually does something here. So this method here, this returns an integer, and I've called it get42. Let's get rid of that. Let's say we want a method that adds 2 numbers together. So how would I do that? I would define it with a return type. So we'll go with int again. We will call it add, and in this case, it's only makes sense to add something that you as a method user supply to me. So this is what a parameter is. So a parameter is a data type, a variable that the caller of the method supplies to us, to the method, and that we can use inside the method. So let's say in this case, we have an int supplied as the first number and an int as second number. And what we're gonna do here is, it will be very simple. We're gonna return first number plus second number. So all we do in this method is we get 2 integers, and we add both together here, and then we return the result. So let's use this. Let's say add 3 and 4. And we could also, let's start by doing this. Output the result here. So you can see that we added all of this together to 7. But we can also supply more of this as a parameter. So let's say I want to call this again. And let's say I say result will equal to add result and result. So what this is going to do is we pass result as the first parameter and the second parameter again. And I say, please add those together. So this works as well. And the result of this, the result is a bad variable name here, but the result of this method call will be returned and assigned to this result variable. So what this will do is we add 3 and 4 together. This will be 7. Next we call this again, pass 7 and 7 here, which will be 14. And this result will be basically assigned to the left-hand side here. So the result should be 14. So as you can see, it's 14. So this is how you use parameters, basically. Let's get rid of this. Let's say we want to define a method that doesn't have a return value. So you could, for example, say, I want to have a method that's called greeting. And this method is called multiple times to greet the user. We could do this by typing void, which means this method has no return type. I'm gonna call this greeting. And let's say, let's start like this. Let's output simple hello you. So you can call this again and again, and it will basically do this output 3 times now. So as you can see down here, we have called this method 3 times, which outputs hello you 3 times. So you could increase this or improve this by maybe saying we have a parameter string username here. And this would be, let's say we're gonna greet the user here. It's uppercase N. And now I've changed the method here. We have new parameter username, and we actually want to greet the user here. And this void means we don't return anything. We simply do something. Now these red squiggly lines here tell me that, well, I'm missing this new parameter here when I call the method. So what I have to do here, I have to pass a username. So this could either be Simon, Jane, or I could, as you've seen in the last example, say username equals John. I could also pass this variable here. So in this case, we first greet Simon, then, Jane as the second greeting, and the last greeting will be John. So this is our last call, and this time we supply the username, which will be John. So let's try this out. So here you can see we have basically repeated the same code 3 times, this line, but we've only changed basically the username, which has been supplied as the parameter. So this is basically the dynamic part that we can use in a method. One final note here. Consider this console.writeLine, convert to int 32, int try parse, console.readLine. Those are nothing else than method calls. So if you hover over this write line here, you can see this is a void, so it doesn't return any value. Console.writeLine method that takes a string argument that's called value. And here you can even see a description of what's done here. So we've used methods all the time in our tutorial, and now you understand how to create them yourself. So the first task is to get the code that I've shown you that gets a user input as an integer, and use this code to extract a method that you can call over and over again that does all of this for you. So consider what should be the return type, what should be the parameter maybe, and yeah, create a method out of this. Let's build a solution here together. This is a code you know. So first we have a user input. We ask the user again when it's not parsable as an int, but when it's parsable, we convert it to a result variable. So we would like to extract a method here. So we first should think from the outside, how should this method look like? Well, what we want to have is we want to be able to allocate an int, say user input number as a variable name. and we should be able to get this from a method call. So we could name this get user input number. So this is how the method should look like, and this is a method call. So in this case, this should supply an int. How do we extract the method now? Well, first we have to type the return data type. So in this case, this must be an int. Next, we type the method name, the parentheses here, curly brackets, and we move all of this code in here. Next, we add a little white space at the beginning because it looks much better and we can understand that this is actually a method. All of this code in here. And there's one last thing we have to do. So this code, this error, so VS Code helps us here and tells us not all code paths return a value. And this is because we never actually return anything, but we must return this integer here. So in this case, we allocate a result variable, but we don't want that when we call a method. And in this case, we don't want that because this should be the return value. So we remove that, type return. So we will actually return from the call this conversion with a conversion result. So let's try this. So this code was a little buggy here. So let's enter AAA. So that's not a correct input, but when I enter 42, I can see that this has been worked. So let's put this to the user. And now we can see that this actually worked. And what you can also see is that we can use this multiple times. So when I repeat this and say, maybe I want to get 3 numbers from the user, we don't have to copy any code. We simply invoke this method 3 times. And I can output this down here. Your numbers are. So let's try this again. So let's say 1, 2, 3. And as you can see, this works as well. So no copying of code needed. We don't have to change all of these code places here. Instead, we have just one place where we can fix things or change things. So we could say, please enter a whole number. And this would basically change all of these inputs here. So I hope you can see that this makes our code much more reusable, and it will be much more easier to maintain this code in the future. So methods are also used to structure your program. So maybe a higher level method is called first, and this higher level method will call a lower level method or call multiple lower level methods. And this is basically a way to structure your program and solve different problems individually. So in this example, I want you to create or calculate the area of this house. It's a very stupid 2D calculation. So what you should do is you should create one method that I simply call that calculates the whole area of this house. And this method should use submethods, so 2 new methods. One that calculates the area of this rectangle here, or square here, should be square. And one that calculates the area of this triangle here. So please go ahead and do that. Let's solve this together. So there are 2 approaches to solving these type of problems. We could either start at the top with a high-level method first and go and work our way towards the bottom methods, so the low-level methods. Or we can start at the bottom and work our way up to the top. So in this case, I would like to use the bottom to top approach because these small methods will be much easier to create. So let's first start by creating the method that calculates the square area here. So in this case, we need the length of one of these lines here. So let's call this A, for example. So let's say I'm going to calculate this area with a double value because it won't be an integer in the real world. Let's say I'm going to call this get house basic. Let's call it this get square area because it will be reusable across other domains or other application areas as well. And for this, we need the length. So this would be the first parameter here. Oh, sorry. And this is basically going to be return statement, and then we're going to type length times length. Next, I want to create the triangle area here. So for this, we need the same length here, but we also need the height. Let's create this. Let's call the first one length, and the second parameter, this should be height. And in this case, we're going to return 1.5 times length times height. And finally, we can create the last method. So this should be double get house area. And in this case, we need the length and, oh, sorry, it's double. And the roof height. And in this case, what I'm going to do is I'm going to basically allocate the first variable. It's going to call this basic. Let's call this living space, living area. And this is going to get calculated by get square area. And going to pass the length in here. And the next one will be the roof area. And this is going to be calculated by get triangle area, length, and roof height here. And we're going to return the sum of both here. Because we're going to have to add this area and this area. And we can test this by basically saying console.line house area, and let's try this with 5 and 3. And in this case, the basic area, the living area, this will be 25. And then we have 5.3, which is 15. And we have to basically halve this, which will be 7.5. So the result is correct in this case. And I hope this example makes clear that you can structure your bigger programs by basically composing these of different smaller method calls, where you can basically place the logic to solve a simple problem. And by combining the solution of these simple problems, you can create solutions for bigger problems. Finally, we're at the last part of this C# fundamentals course. As you know, C# is an object-oriented programming language, but we've never actually talked about objects. So let's resolve this and dig into classes and objects right now. Before we start, I would like to show you the motivation why we actually use classes and objects, and why nearly every new programming language is in fact an object-oriented programming language. So in the past, when there were no object-oriented programming languages, you usually had your code organized like this. So it depends on the actual programming language used, but it mostly looked like this. So in this example, I'm going to use the sensor again. So we imagine that we want to use some sensor value that is obtained from some sensor that is sitting physically somewhere. So in order to basically use this in our program, we might have a double array. So this is the actual sensor values. So this might occur somewhere in our code. Next, we would also have maybe a count. So this would be the count that the sensor has obtained, so the number of sensor values. We might also have a method that adds a new value to these sensor values here, because we might do some transformations to these sensor values. Next, we might have a method that actually gives us the average of all sensor values. Next, we might also have a highest sensor value that is stored in the array, and we don't want to basically write a for loop, and every time when we want to know what is the highest sensor value, so maybe it's a temperature, and then we don't want to iterate over the whole array to get the highest value. So we store this in a separate double variable. Then we might also have a method that outputs the last values, so maybe the last 10, 20, or 30 values of our sensor. Next, we might also have a median value, and then a method to output these values as a string. So we can output this in the console, etc. So you can see here that our code gets more and more obfuscated. So when you don't take special care, at least, then it will become a mess quite quick. So most of the methods here actually only operate on this sensor value data here, and on the other hand, the data here actually belongs to the methods that use these data here. So there's actually a good connection between the two, between the data and the methods. But in a lot of code bases in the past, it was the case that the code and the code that's using the data and the data itself, mostly variables, these are not combined into one single construct, not combined into one single entity. So this can get a mess quite quick if you don't take special care. So what has been done is these here have been combined. So we basically, this is the idea of a class, combine all of these methods and data together into a single entity that's called a class. So in this case, I would name this a class sensor, and this would basically consist of these variables, so the sensor array, the double values, the count, and the highest number, and all of the methods that operate on this data also. So this is the main idea behind object-oriented programming: combine the data and methods that belong together in a class. So what's a class now? So a class, as you have understood by now, is a combination of data and methods. But it's also one more thing that's usually quite handy. So when you have defined a class in your code, you can also create multiple objects or multiple instances of this class. So this would look like this. So when we create the first instance, this would look like this. So we have a class that's basically a template of the object that we want to use. But when we have defined the class itself, so in code we cannot actually use the class itself, we first have to create the objects, one or multiple objects. So in this case, I've created one object of this class that has its own data and its own methods based on this class template. So we can also create multiple objects of this class. So let's create another one. So in this case, basically we have created object 2 based on the class template. So to get more concrete, you can see an example here of the sensor with only 2 variables or 2 data types here, or 2 variables and 2 methods. And in this case, we maybe have a class sensor that has a double array, double max value, and 2 methods. And we've created 2 two objects out of this class. So maybe an inside temperature sensor that basically is represented by one object on the top right here with different data, and one outside temperature sensor on the bottom right here that has its own data and the methods that only operate on this object itself. So the methods that you use operate on one instance, one object, so a specified variable, depending on how the class is defined, of this object. So that's the important thing when we talk about objects. It's basically one instance of the class, one copy, so to speak, with its own variables, and we can then invoke methods on this object. And those methods, so when I would add new value, this method on outside temperature sensor, this would only add one value to the array inside this object. So this will get more clear when we go into practical examples, but I hope this is a good overview for now. I would like to go into some common mistakes that I hear quite often, and I don't think you should think about object-oriented programming that way. So one thing I hear all the time is that classes are used for modeling the real world. And yes, you can use classes or objects for modeling something, some abstraction of the real world, but it's not actually used that often in programming. So yes, our programs are usually helpful for running processes in the real world, but if you think about it that way, that's not usually how classes are used in programming. So when you're in the real world and use a program, 99% of the classes won't be represented in some real world construct. So I would rather say classes are used to modularize your program. So these are the modules of your program, and you can use them to represent abstractions of the real world. Next, you always have rule-based class composition. So there are some rules like only single responsibility, how to decompose something into a class that in practice are often followed very strictly and don't lead to a good design. So don't be too strict about your class design, simply follow the rules that make sense. So we'll go into more details about this in another tutorial, but for now, don't be too strict if you ever hear that you should simply, maybe only use, for example, 10 lines of code for every method, or 3, or let's say 100 lines of code for a class. Those rules are usually not very helpful in practice and don't really help your class design. So don't get into those specific rules. Simply think about what makes sense to put into a class where the data that belongs together should be also basically be represented together. So when the data belongs together and the methods belong together, there shouldn't be strict rules about how big or large a class should be. And lastly, there's often a misuse of concepts like inheritance. We won't talk about that for now, but I just want to make you aware that in practice, there are a lot of concepts that you can use additional or basically combined with object-oriented programming. One of those is inheritance. There are other concepts as well. And what you can see in practice very often is that those are overused or misused very often. So don't get into the foolish way and just learn about a concept and overuse it all the time. So just take a step back, relax when you think about a problem, and make sure you use the concept the way it's supposed to be. So in this case, put data together with methods that operate on that data. In order to use classes in C#, we have to learn about some more keywords. So I want to do this by an example, and the example should be a system where we record cars in stock and car sales. So let's imagine we are a car sales manager and we want to record all of this data. Then we would want to build a system that records these for us. And in such a system, we would like to store information about a car, obviously. And that would be a natural fit for a class because we store some specific information that belongs together, and maybe we want to use methods that operate on that data. So how would I do that in C# now? I would start by creating this car class, and I would type class. This time I called it car, so this is a name of the class. Then I have two parentheses here, curly brackets, and inside these brackets we have the contents of the class. So in this case, the contents of the car class. And the contents are mostly fields and methods. So in this case I only have fields, but you could also put methods in here. And the fields are an int, years old. So fields are basically the same thing as variables, but with the difference that they belong to one class specifically. So in this case I have this years old integer in order to basically record the age of the car. Then I have the model name as a string, and I also have the manufacturer as a string. Okay, and as I've told you, you don't want to use classes directly because classes are basically a template in order to create objects. So you don't want to use classes directly. You first create objects of a class, and this is how you use them. So I want to do this by creating one object. So I would do this by typing car, then I would name this variable. So this is an object, but it's of type car, not int, string, etc., because this is basically our own class type now, similar to string and int. It's called my car, and then I type equal to, I have to type new, and new is basically a keyword that says create a new object here, and then I type car with parentheses here. So this basically creates a new object, this right-hand side. Then I want to use the fields of my object. In this case, my car dot years old is assigned a value of 10. And I do the same thing with the model name and manufacturer here. So in this case, you see that we have still these red squiggly lines. So there's something wrong here. So the error says it's inaccessible. And this is caused by the class system here, or the type system of C#, because in C#, all of these fields are not accessible outside the car or outside the class where they are defined in. So in this case, in order to make this work, I say public, or I type public in front of the field, which makes the field accessible from outside here. Okay, so I have to do this with all of the fields. Okay, and now I can use them basically. And let's output some values of our class now. Sorry. So let's say output my car dot manufacturer plus let's say from here I actually want the model name. Okay, so let's try this out. So as you can see, we've now output the values of our object, one car, and we can use it in our program to store the data, the fields together in one object. Good. Now let's say I want to create multiple objects here. So let's say I have multiple cars in stock. I can simply copy this and adjust the variable name. So let's say in this case, I'm gonna make it very simple. So I just call this my car2, which is not the best name, and my car3. So let's say in this case, we have some other model or the same model but older. And in this case, we have a brand new Volkswagen. And then we can output this again. And we could also output my car 3 here. So this is how you can create multiple instances of the class. So in this case, multiple objects. So my car3 is an object, my car2 is an object, and my car is an object. And they basically share the same fields. So they're not shared data-wise, they're copies. Maybe it would make sense to show you this really with car3 as well, because my car and my car2 are actually the same car model and manufacturer. So when I make it more obvious, let's say my car3. So here you can see we have also Golf from Volkswagen. And this makes it quite obvious that all of these variables here, my car2, and my car3, they're all car or cars. So they share the same class, but they are different objects. So they have the same template, the same structure, the same fields with the same name, the same names, more precisely, but they don't share the same content of the variables. So this my car3 has different variables, so to speak. So different memory location where we can store all of this data. So this is why we've output this 2 times, and this basically is a new object with new data, new variables, or new fields more precisely, which is basically a different memory location. But we can still access them the same way by typing a dot and then the field name. So this is how you can use multiple objects. And now I want to go into default initialization. So let's say we don't have 3 cars, but we're a big car salesman and we have thousands of cars. And most of our cars are new. So this would make it more sensible to assign a default value to this field here. So instead of saying to each and every new car that it's basically 0 years old, we can instead assign a default value down here. So this would say, hey, years old is whenever this car is created, set to the default value of 0. We could also put some other value in here. We could also put a default string to model name and manufacturer, but for me it's enough to say that this is a default value. So when I get rid of this line here, we'll see that. Let's output this again. Car 3 years old. So you can see now, when I execute this, that it's basically set to 0 by default, because we've never actually assigned a value to the Volkswagen. It's set to 0 down here as a default. So all of the cars have set it to 0 by default, and unless we override it with a different value, as we've done with the first 2 cars, unless you do that, all of them are initialized to 0 by typing an equal sign here and the default value. So I would like to point you to one specific thing here. Take a step back and look at the object creation here. So we basically type new, then the class name, and then parentheses here. So this looks similar to a method call if you would remove the new here. So the new is telling C# create an object here, But this here, behind the new, this looks like a method call. And in fact, this is basically similar to method call, a very special method that's called a constructor. So we cannot see a constructor when we look at the code of this car class, but it's basically created automatically if we don't put it in the code itself. So whenever I type, let's type it out. This is the default constructor. So this is created automatically, even if we don't put it into our code. And what this is doing is, whenever we create this object, or we create an instance of this class, that is the final object, this method, this constructor is called. So we don't do anything in here yet, but we could, for example, set the initial value of years old inside this here, inside this constructor. We could also set, for example, manufacturer to some default value as well. So in this case, I could remove this line, and it would still be the same result. So you can see it's still the same result. So this is what a constructor is. It's basically a method that is called to construct an object. And what's very interesting here is you can actually have multiple of those constructors in a class. So it's now your task to add a second constructor, and the second constructor should take all of the important arguments that you need to construct a car class. So think about what's important here and create a second constructor. So your solution might look like this. We have a car constructor, a second one here, public car, and then we have these three arguments or parameters. And in the curly braces here, we have basically an assignment of this variables years old to the years old field, etc. So your solution might look like this, but I want to show you that this is in fact not working in practice. So let me comment this out, these two lines. And when I now pass, so these lines are not executed. And when I use the constructor now, pass 0 years old, model name, Golf, and Volkswagen. Let's execute this code. And now you can see that this is a and an empty string from empty string. So this hasn't worked. Why? Well, the solution here is, or the problem here is, that this parameter name is the same as the field name. So when we're in this constructor here, this parameter name masks the field name. So that means when you're referring to this name inside of this constructor, it's actually referring to the parameter, and we're only assigning the same value to the parameter. So we can fix this by renaming this and maybe putting a P in front of here and saying, well, for P for parameter, and assigning the local field name to this parameter, or assign the value of the parameter to the field name. So I want to show you that this does in fact work. So I fixed model name now. And you can see that model name is in fact the output here. But it's kind of ugly. So because this name and this name with the P in front of it, they have to be different, but they refer to the same name, the same field name finally. And that is not good. I don't like that. So what we can do instead is name them back. So, and now what we can do is we can put a this in front of the local field. So when we put a this here, this refers to the constructed object, to the new constructed instance. And that means years old will be, or this.yearsold will refer to this field and not the parameter here. So when you put this in front of it, it refers to the local object and the fields of the object. So this should now basically fix the problem. So let's execute it again. And as you can see, it's now worked. Okay, so let's repeat this. So this is a keyword and it refers to the current object. So in the constructor, this refers to the current object under construction. So the currently initialized or object that's currently initialized. And then with a dot, we can access the fields of the object. And in this case, we assign it to the parameter value. So you can use this keyword more specifically. You can use it also in method bodies. Good. One more thing that I consider very important when talking about constructors. So we have this constructor here, the public car constructor with 3 parameters. And this makes sense if you think about it, because when we have all of these parameters available, we can construct the car, the object, in a state that's very good because we have all of the data available. But it might also be that we don't have all of the data available, for example, years old, and then we might use another constructor. But yeah, this constructor doesn't make much sense because it sets manufacturer to a default value, which in many car sales systems won't make any sense. So in this case, it's much better to have maybe a second constructor that has both of the other parameters, and then set the years old to a default value, because manufacturer doesn't make really sense that this is a default value unless we are a specific dealer for a specific brand. So let's set this to something that makes more sense. So we have 2 constructors now. One that doesn't set the years old, or that sets years old to the default value, and one that basically sets it to a provided value, to a provided parameter. And I think the car class makes sense if you think about it with these 2 objects, or with these 2, sorry, not objects, with these 2 constructors, because now I don't have a chance to construct the car object in a bad way, in an invalid state, so to say, because we have to provide model name and manufacturer in any case. So as you can see, this is now invalid because this would mean, hey, we construct a car object in an invalid state. So in this case, I have to set the value up here in the constructor. And as you can see, now it's also providing a suggestion how to pass the parameters here. So can delete these lines and re-execute it to see that nothing has basically changed. Yeah. Okay, so that's important. Think about how many constructors make sense, such that each constructor initializes or constructs your object in a valid state. Great. So one thing we haven't followed so far is the convention that every class should reside in their own C# file. So let's do that now. Go to Explorer here. New file. Sorry, click down here because I want to be that the file should be located next to program.cs. Let's call this card.cs. Let's copy all of this code in here. And execute this again, just to make sure that everything works as expected. So we've now basically placed one class in its own file. This makes our code much cleaner because we don't waste this main execution method here, this main program flow with all of our details of the car class. Now I would like to show you that you can also use methods in classes here. So let's create a method that calculates the registration year out of the years old. So in practice, you would usually do it the other way around. You would store the registration date and then calculate the years old out of that. But in this case, I'm gonna do it the other way around, just to make it simple. So we first have to say public here because we want to make this method accessible outside of the class. We would put private in here, which is another value, which we'll talk about later. Then this would only be accessible in here. I'll show you that in a bit. Say I want to return an int. Say registration year. And return the current year minus years old. So now when I go into this program.cs file, say my car2 dot registration year, call this method. Sorry, uppercase C. Then this should be 2005. So yeah, that's 2005. And this shows you how to use methods in here. So you can use methods that also take parameters. So you could, for example, access this as a parameter. You could pass other things, strings, other parameters other data types as a parameter, or basically make this method call other methods, etc. So you can make this as complex as you want. Important is that you can, or that you style your program in a way that makes it easy to understand what's going on when you have another look at it. Let me show you an example of private methods, or private as an access modifier in general. And I would like to do this by adding a feature interactively. So in this case, I want to track the sales price of a car. So we should start by adding a field here that basically stores the general price, the net price of the car. And what I would also need to do is I would like to add a method. I'm gonna call this get sales price. And in this case, I'm gonna return the price field. So in this case, we just simply return the price value. So this keyword, you can see it's the Visual Studio Code marks it as not needed here. So it has a very dark color. So you can get rid of that because there is no naming confusion. There's no parameter that has the same name, so it's not needed here. We can get rid of it. And this in the simple case, we just return the price in this case. But I want to make it a little more complex. So I want to add a sales tags. So I want to add a field called sales tags. Return that. So this, we could add it here. And this can be 1.1, sorry. Okay, and one note here, there's sales tags. This is a fixed value, so we can make this a constant. So I haven't talked about constants before, but the const keyword basically marks this field, this variable, as constant, so you cannot change it. So it's one time in the code, you cannot change it anywhere. It will remain fixed unless you recompile your total program. So no way to change it. And this is basically very good because we don't want to change the sales tag somewhere in our code. Next, I might also add a constructor argument here. Decimal price, this price equals price. And in this case, I'm just gonna set it to some default price. Okay, so let's say there is also possibility of bool flag and when we have, let's say it's called super sale, and when we have a super sale, so let me set that to true. When we have a super sale, like in this case, then, well, we're gonna offer a discount for the car. And this discount is calculated in its own method. And this would be a suitable logic that we could encapsulate or basically put into its own method. And then we're gonna call this, we're gonna type private here because this is only gonna be used inside of this class. Gonna return a decimal. And I'm gonna call this apply discounts. This makes more sense. And we're gonna take the original, let's call it original price. So in this case, we simply return. So we have a discount. And that it would be, yeah, maybe 10%. And what I'm gonna do here is I'm gonna, yeah, basically say original price times. Let me make it with an if statement, of course, because we need if we have a super sale, then we're gonna apply the discount. So we're gonna say, let me show that you can also store the result value somewhere. So in this case, the result is gonna be the original price times 1 minus the discount. So this is a fixed discount in this case, but it could also be some other discount. We could get it from a local field as well, or from some other value. And in case it's no discount, I'm gonna say result equals original price. And finally, we're gonna return the result here. So this is some logic that is basically applying the discount. We could refactor this to a way that's more simpler, more cleaner code, but yeah, it's fine for now because this shows you that this is basically some logic that makes sense, that is an individual unit of code that we can basically put into one method, and this method is never going to be used outside of this class. So it's a good way to mark this as private, because when this is marked as private, no user of this class, no external user, like this program file here, or maybe some other customer of you that uses your classes, they can never actually change the code in here because they cannot call this method directly. we can only call it from the inside of this class. So in this case, what we're gonna have to do here, when we get the sales price, we have to basically, either make it this, but let's make a new variable and call this apply discount price. So the price that has the discount applied, and let's make it the other way. Sales price equals price times sales tax. And in this case, then we apply the discount as a final step for the customer to see a bigger number here as the discount. So what we are going to do here, we're going to say apply discounts, which returns a decimal, and then we're going to pass the sales price in here. So it will be a simple method because we only add a sales tax here, but yeah, we will also apply the final discount in case that's suitable, in case this method handles it all. And this is basically determined by the isSuperSale booled variable here. Okay, so let's test this now. We have to add the price for all of these models here. Say 11,000. And let's test. Sales price. Okay, execute this. And you can test for yourself that this is in fact correct. We have added the sales tax, which is 10%. And then we've basically reduced the total amount by 10% discount. Now that you've understood the private and public access modifier, it's a good time to change all of the fields of the car class to private, because it's generally considered a bad practice to make things public, and it's a good practice to make things as private as possible, because whenever you make something public, it can be used anywhere in your program. And whenever you change something about the public methods or fields, they have to be changed all around your program. So it's a good idea to make the fields private. And I would also ask you to add getter and setter methods for those fields. So you can basically make one method for getting the value of the private field that is public. So the getter method itself is public. And also a public setter method. And the individual setter method is used for setting the value of a specific field. So in this solution, I have changed yearsold to private. I've added a getYearsold method that is public, returns an integer, and it returns the yearsold field, basically. And I've also added a method called setYearsold. It's void return type, so it doesn't return anything. It's public, and it basically takes a yearsold argument and it sets the internal yearsold field to the yearsold argument. So when we have a look at the program now, we see that because I've changed all variables, or better name would be fields here, to private, we cannot access them outside of this class here. So we cannot access them in this program.cs file. We can only access them inside the car class. So we could change this to getYearsold, and this would work. So you might ask, what is the benefit of this? Well, the benefit would be that you can return yearsold here, but you can also change the internal implementation. So maybe you don't store yearsold directly. You might store a registration date, and then you can simply make a calculation here to get the years old of the car, and you wouldn't have to change any consumer of your class. So you wouldn't have to change any code functions that used this method. So that is one way to do this. I haven't added the getter and setter for the other private fields here, because there is a smarter way to do this, and that is called properties in C#. So instead of doing this, we have a built-in mechanism that makes it faster to create this behavior of years old. So instead of doing this whole code here, there's a fast way, and this is public int years old. Usually when it's public, then it's written uppercase. Then I type curly brackets here, get set, both with semicolons at the end. And now I can delete all of this code. Simply have to change this because it's not uppercase. I have to change it here as well. Okay, but this is basically saying I have an internal field, years old, and I can get and set this with specific methods that I can change later. And it's an int field. So it's basically the same behavior, 2 methods and an internal field as before, but it's basically much shorter. And I can also use this by typing years old here. So it's accessed like a field, but under the hood in C#, this will make a method call to the getter of years old. So there are more details to getters and setters and properties like this, but I briefly wanted to mention this because it's used very often in C#, and I wanted you to get a small overview over getters and setters. If you want to know specifics, for example, how to change the setter method later or the getter method, I'm gonna do that in a more specific tutorial. So let's change these as well. And now we can re-execute our code. So all works fine. And note that I haven't set or haven't created getters or setters for these methods, or these fields, sorry, for these fields, because they are not needed. They are not needed anywhere in our program, so it's not a good idea to make them public or create properties for this, because they're not needed. Static is another important keyword that you should know about. Let's say we want to keep track of all cars that we have in stock, or all cars that we have created as car instances here. And in this case, we want to keep track, as a simplified example, how many cars have we initialized? So how many car objects have we created in our program? And we could do this by simply saying we have an int variable called counter. We initialize this to 0. And whenever we create an object, we simply say counter ++ like this. But if you think about this, it's not a really good idea, because the car class could be used all over the place in our code. And this would make it very confusing, because every time we create this car class, we would have to remember, hey, there is a counter variable that we have to increment here. And that is basically quite a bad design, because it's prone to errors. If you forget it once, the functionality won't work anymore, and we will have a wrong result. So let's get rid of that. A much better idea is to go into the car class itself and have a counter here. So let's say we have a public field. We initialize this to 0. And we could basically increment this whenever we create this car object. However, currently the counter variable is local to each object. So each object has a copy of this counter variable. This is how classes and objects work. So every creation will put a counter field to each object, and each counter field will be 1 after the creation. So this is not what we want, because it's not shared between all instances of the car class. And a way to do this, to tell C#, hey, this field or this method should be shared, is to put a static keyword in front of you. So this static here, this tells C# that this counter is not sitting directly inside of each created car object, it's rather sitting at the car class itself. So it's shared between all instances. So each instance, every time a car is created, it will use the same counter variable. So I can show you this. We can say console.writeLine we have, and then we have to go to the car class itself and not an object. So we have to type car.counter because it's shared between all instances. And let's press F5. And now you can see that we have, in fact, 3 cars in stock. And whenever this has been created, so to explain this further, or again, whenever the constructor has been invoked, it's accessing this constructor. All of these variables or fields are local to each object. So it's different for my car 2, and my car 3. But the counter variable is static. So this means it's shared between all of these instances, all of these 3 instances. It's only one field, so to speak. And this is why we can count cars, the car initialization with this field. In this exercise, I want you to create a sales manager class. The sales manager class should track which cars are in stock, and when given an index, it should also return the car for a sale. So don't make it too complex. It should be a very simple program. This is a very simplified example of a real program, of course, but I want you to see with this exercise that you can use composition of classes in order to solve a problem. So I've created the sales manager class. It has a car array, so an array of cars, and we can store 100 cars in here. We also keep track of the number of cars in stock. We have a method that adds a car to stock. So when given a car, we place a car in our array, and then we increase the number of cars in stock int variable, the counter variable. We also have a sell_car method that takes the index of the car as a parameter and returns the sold car. So in this case, we go to the index, get the car of the array, and get this car stored in a local variable called car. We could also rename this to car to be sold. Next, we set this value to null. So null is a special value. We can set any object or any class variable to null, and setting something to null means this doesn't have an object here. So whenever I have a class like car, my car, I set it to null. This means this here doesn't have an object instance, so we cannot use this in this case. So in this case, I reset the cars in stock to null because I don't have a car in stock at that index location anymore. If you want to do this precisely, you would have to reorder or resort the cars in the array because you want your array to start with the real objects and not the null values. So it would be a better solution to resort the car array here. But I want to show you this as a simplified example. And I want you to understand what null is and how you can use classes in combination with each other. And then we reduce the cars in stock by 1 and return the car to be sold. So as a consumer, I can say, hey, I have my cars here. I have a sales manager. I add all of these cars to the manager, can sell at a specific location, can output the car details, and also the price. So this is a very, very simple example that should illustrate you can use class combinations or compositions of different classes in order to solve a given problem. Congratulations, you have learned the fundamentals of C#. You've learned what variables are, different data types, how you can use those and combine results in operators, how to use methods, what classes are, and how you can use different or multiple classes to solve a bigger problem. So I want to show you here that in C#, in fact, we have another class in the program.cs file. We can basically press Control period and say convert to main style program here. And when I do that, you can understand, this is not important right now, internal, but you can see that we have in fact a program class in here and a main method that takes some arguments. This is an array of strings and it takes some arguments. And this is the entry point of our program. So in reality, this program.cs file was all the time a class. So you can execute this again. And it still works the same. So we've used classes all the time. We've actually used classes when we executed a method like console.writeLine. You can right click on the console or press F12 or go to definition here. And here you can see that console is in fact a class 2. It's a different class. It has a static modifier here. You can see namespaces that I haven't talked about and using statements that I haven't talked about, but it's basically nothing else than a class. So I've decided to end this fundamentals course here. So take a step back, tap yourself on the back, and I'll keep you posted for more content. I'll record some more videos about the specific topics that I've mentioned earlier, but those are worth a deep dive. And as such, I recommend you to watch my other videos. So click the subscribe bell if you want to know more. Otherwise, see you next time.